We live. Let's see. Test. Okay, we got Alan in here. I'm gonna give you the inside of the chat. I'm gonna give you the link quick.
Okay.
Okay. Join in. Let me grab something real quick. Let people tune in real quick. Arnav, sure. 100% you can interview. Give me a sec. Let me send you the link. Oh, nice, Alan, you're in here? Okay, wait. Let me just send.
I mean, yeah, I'm in here, so I think it works. I think. Yeah, I see the cursor on my
Nice.
on your stream. Yeah.
Okay, I'm just
So I think that's good. Get the meta glasses.
Meta glasses.
Meta glasses?
They're nice, I know for sure. But like,
I've
I
never
barely get a
tried it on
discount.
before.
They're pretty
My
popular
friend
now. It's
bought it and
crazy.
he was
Did
my
you
friend
like
bought
it?
it and he was having fun playing VR and I was like, that's so cool. And then after like an hour he was like sweating and he's like, let me take a break.
On the glasses, he's playing VR. That's crazy.
I think so. I'm not sure.
Or did he
But
get
yeah.
like?
Or I think or maybe he was using the old Meta
Yeah.
VR goggles. Yeah. Buy them for me and let me reimburse you since you get a Meta discount.
Peyton, where are you based? Let's see. Wait. Just need to update some hours real quick. 1 to 5. I'm gonna go watch the game after. Just gotta send the link. Karnav, check this out. Book here. See what slots shows have open. Yeah, no more today. 19th. Yeah, Juneteenth. I'll do a bunch. Chat, how's the audio? Chat, give a thumbs up if the audio is good. Wait, let me test on that.
Let's see if I can access a stream on here.
Nice. Alright, everyone's saying the audio is good. Let's get straight into this then. Coding interviews. This is always fun. Now that I have a list of questions, it's better because the annoying part for me is trying to find good questions on the fly. But now that that's why it was nice to like look over all the good questions.
Okay. I'll let you know if it's a problem I've done before.
Yeah.
Or if you want to still test that, that's okay as well.
Do LeetCode 3.
LeetCode 3.
Okay, chat's asking why use CoderPad? CoderPad is more like what people actually use in the actual interviews. LeetCode has like boilerplate, and it has too many test cases.
Oh, LeetCode collaboration? I've never heard about it.
Yeah.
LeetCode has collaboration? Oh wow.
Yeah. Okay, let me look up LeetCode 3. Let's see if it's a valid question. Have you done this question? Longest substring without repeating?
I think I solved it before.
It's all good. I don't want to do that one.
But it has to be some time ago because I can't immediately think of a solution.
Alright. Let me look
But either way should work.
Yeah, let me
Probably.
Okay, you're in here. Cool, I'm gonna start up a video. What school did you go to again, by the way? Just for the intro.
Oh yeah, went to UT Arlington.
Nice.
For
Longhorns.
No, that was my bachelor's.
Oh, okay.
My master's is in Arlington.
Oh,
But
you
bachelor's
have a
I was in
master's in computer science.
yeah
Wow.
yeah. But my bachelor's was in electrical engineering, and I didn't like the hardware part.
Wow.
That's why I switched, and then got a job as a web dev. But the title is software engineer, but feels just like web dev only.
Your current job?
Current job? No, was just
Yeah.
searching for jobs.
Is the job market good over there?
Pretty bad. Pretty bad.
Yeah, honestly. It depends on like how much experience you have too.
Yeah, because my experience is like 2.5 years, which is not enough. It's just still like entry
Yeah.
for most companies.
So let me check the mic. Perfect. All right. Hey everyone. So today we have a master's student from Texas. So yeah, they have. You have a bachelor's in electrical engineering, then you took a master's in computer science.
Yeah.
Nice. Oh yeah, just give a quick background on yourself for the chat.
Oh, okay, yeah. Basically, I had like 2.5 years of experience. Title was software engineer, but it was doing like React web development, Node, JS backend stuff. But now, like I'm in my bachelor's, I was in like electrical engineering, but I didn't like the hardware part, so I switched to software, computer science for my master's. Finally in master's, and then starting 2022, graduating 2024, and bam, the market is like one of the worst it's ever been. But yeah, still trying to going for like actually solving legal questions in like a good interview environment rather than just staring at the screen and just like coding silence.
Mm-hmm. And then for context, Alan has solved over 900 questions.
900.
For how many?
Yeah, but 900, let me see right now, 929 questions, but over half, 500 of them are like easy, 370-ish medium, and only 30 hard.
Nice. Yeah.
Yeah.
Still a good amount. Like
And
you still got a lot of
yeah,
breadth. Like medium
I
questions
did
are. Oh, go ahead.
lead code contest, but so far my ranking is only like 1674, so it's not like super good, just there.
Yeah, that's. I think that's still good. That might even be higher than mine. I did like one or two, and I only solved the first question. But let's see. No,
Lead
like
code.
yeah, this is good stuff. And you said that you're not really used to all the time you've been doing all these leak codes. You've just been
Not
doing it in silence.
80%, 80, well, recently is trying to talk to myself,
Yeah,
like trying to pretend I'm in an interview, talking to myself, like writing comments, like doing it. But most of the time, especially during like lead code contests, it's just like in silence and then like typing it out and then debugging using print statements, which is not like a good way to dry run things.
yeah.
So my approach isn't like interview style friendly.
Okay, let's see. Let's see how you do here. How are you with the different questions like graphs, arrays?
I would say weak, weaker in greedy, advanced graphs, intervals, those kind of questions. I did like 100 some questions in Neat Code 150, and let me see here. Yeah, some of the math questions are okay. Greedy, yeah, and then dynamic programming, the more advanced dynamic programming problems, backtracking, these are my like weaker areas.
I see. Oh, like oh, wait, what is your weaker areas?
Like backtracking, advanced graphs,
Advanced graph.
like more difficult dynamic programming.
I see. Okay, sounds good. All right, let me think of a question. Okay, we'll do some warm up. We'll do one to two questions. We'll just see. Depending on how you do, we'll move on to more questions.
Hmm. Okay.
Um, so for this first question, So we're gonna be given a root of a binary tree containing digits from 0 to 9 only. From each root to leaf path in the tree, it represents a number. So
Mhm.
I'll show you what that looks like in the drawing. So we're
I
gonna.
think I might have done
Oh,
this
you've done
one
this
like
question?
an hour ago actually.
How
I
was
was
it?
because I was going through your
Yeah, yeah, yeah,
75.
yeah. Okay,
I was going through your 75, so I think I did this an hour ago.
no problem. Let's see.
But that's still okay.
Did you do the min
That
stack
doesn't mean
question?
the mince. Which one?
155 in the design questions.
Design. I don't think I really do well in design questions. That's for sure.
Okay, let's see.
Yeah.
Let's try this one because it's more of it's the easier one on here. Oh, they moved it to a medium.
Oh.
Let's see. Give me a sec. Let me think. Let me think.
Yeah, but also like just because I've did it before, that doesn't mean I can perfectly do well in an actual interview
Yeah.
setting. There's a difference.
I'm gonna pause the video while I look. Okay, I got a good one. Got a good one. Let me clear this. Okay, have you done this question right here?
Let's see. Generates all combinations of all form references.
So, for example, if
This
I
one I don't think I did well of it. Even if I did, I didn't do it myself. Yeah. This is the type of question I don't think I would do well in like an actual setting. But yeah,
you want to
I
try,
think yeah. Let's see if I can think of something and try it, yeah, for sure.
yeah. If you can't, we'll just move on to the next question too. I'll give you like 20 minutes to solve this, and we can move on. We can focus on
Okay.
breadth over depth, just to see where your gaps are and stuff.
Yeah. Okay, so given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses is uh yeah, so we want to start with like open parentheses to end closing parentheses and go from there. I want to generate all of them. So this might be a backtracking problem. This is what my intuition is telling me. I think
Mm-hmm. Why are you
yeah,
thinking that?
backtracking. Because I need to try like all different types of combinations. So I need to like one loop will be like, hey, I need to try a opening parentheses, open it again, and then close it and like that. So I think that's what backtracking is good for.
Mm-hmm. Like trying all possible combinations type thing.
Yeah, trying all possible combinations. Obviously, like pruning, like we shouldn't start with the closing parentheses because that's not a valid one. So there are cases where it's not just trying everything.
Mm-hmm.
Not sure how I can start this well. Let's see. I should use something like a stack to track this, and when I reach the end of I guess the index, I want to make a copy of what I currently have on the stack and then push it onto my list of results. So use a result list to uh, to track all the well-formed parentheses
Mm-hmm.
and push to that list when index I is the same as the length or n times 3, n times 2 in this case. So when I get to the end, then I can make a copy and push it on top. Now the problem is during this backtracking process, how can I make sure this is a well-formed parentheses and then go on from there. So
Like, are you familiar with how to implement backtracking algorithm?
um went through a couple of questions for the neat code ones, but in general, I can't really like do it well. I feel like I can't think carefully. Like I know I need to do like a for loop in there somewhere, but where do I start and where do I end
Mm-hmm.
is a problem. So I guess like like doing having like a backtrack and then of an index, and I know I need to do like if I equals to n times 2, then my result will be appended with stack.copy. Like this is like the end case, but for here I know I need to do like a for loop, start from here or something, or then I'm not like I
Yeah.
get confused. Yeah.
Let's think about it a bit then. Like, what is the backtracking algorithm doing? It's building out that recursive tree, right? So
Hmm.
if we go into the drawing, like at some point you have the empty string. The
How
the
do I? Oh, click here to join. Okay.
the goal of the problem is to pretend we're given three, right? We need to generate all the valid parentheses
Hmm.
that have exactly three opening parentheses or three like pairs of parentheses. So like one is like this. This is valid, right?
Right.
Then it's like this. Like there's a few ones, right?
Right.
So that's the goal of the problem. Um, like when we do a backtracking, it's gonna build out some recursive tree, right? So you start with the empty. So
Hmm.
what are the options when you start with an empty?
We can push an open
You can push the
parentheses.
empty.
We can also push a close one, but we don't want to do that.
Yeah, that's
Right.
right. Okay, when from here, how many options do we have? Like pretend maybe we just keep track of how many openings and closings we have, right? So pretend we have one
Right.
opening. Like what can we do now?
We can do a close or another open.
We can like either open it again or close it, right?
Right.
Pretend n equals 3. Okay, what about on this point from this guy?
We can, since n equals 3, we can open again and then or close it.
Yeah.
Yeah.
Okay, what about this guy?
And then after we can't, we already have 3 open, so we have to start
Yeah,
closing.
you just pretty much just
Right.
start closing it.
Right.
And what about this guy right here? Is there options here?
We can we can still open once more, and then we have to start, or we can close.
So you could see how it starts building out the tree,
Right.
right? So I would just like ponder about this a bit and try to figure out how can I write my recursive function to like say to like traverse the tree down, performing making these decisions each time. It's like at each you could think of each node as in like that what you mentioned right here in line 29 is like when you make a decision.
Decision.
Make a decision, right? So here, depending on how many is open and how many closed, you're
Hmm.
gonna either like push a opening or push a close and then recurse, right? That's what's happening in each node.
Right.
So yeah, what are you thinking? Yeah, think about it for a second. Hopefully that jogs your memory with how to do it.
Right. Make it just so right. We want to have like open and close. Know how many open and how many are closed. think. So let's see. If open is less than n, then we want to be able to still push either of them. Else, if open is equal to n in this case, then we can only push a close parentheses. And let's see. Stack, I want to append. And I also want to append a close parentheses. But the problem is, when I append, after I append, do I call backtrack?
I think so. That's similar to like you push this onto a stack and then now you want to recurse in the like what happens here if open is less than n, yeah, open is less than n, then you push this to stack, right? And now you're here.
Right.
And then you want to recurse, you want to push it to stack and then you want to enter this backtracking function.
Yeah.
In
Want to
yeah.
append and then backtrack. But after that, we want to top it off, I think. So it doesn't mess with the stack. So backtrack, it will be open +1, and I'm not sure about the I.
What's eye tracking?
I think where I am right now, but I guess we can just do that using the length of the stack, right?
Yeah.
So I guess we don't really need to do that. So, and then when I append this populator and still,
Let's think about this.
I don't know.
We want to append to the stack closing if open is less than n, but what if open is 0?
Right, open has to be greater than closing. So I guess we should keep track of both values or just use close equals length of stack minus open.
Like the stack minus open.
That would work, I think.
Well, if it's all opens, 2 minus 2 would just be 0. It will tell you that there's 0 close.
Yeah, 0 close. So if only when close is greater than open should we
maybe keep track of open, or maybe just pass in a close as a parameter. Every time you open one, just pass in a close, like increment that.
Okay, yeah, that's probably clearer, better. So open, and then that's still close, and then when we do open, that's close +1. And only when close is greater than open should we close it. And then if open has we already used all the open, we have to only close. And when open plus close equal to n times 2, we know our stack is correct. That's when we can append a copy of it. And we run we start with backtrack of 0 opening and 0 closing. And
Yeah, let's try it on like let's just try it with 1 or 2. Let's try it with 2. Or we need to tell it how what the n is, right? Where's n?
what n is, yeah. So I guess when it's like, what should I call this function? Well form parentheses, and then we're only given an n, an integer, right? And then often, I guess I don't think that's fine. We're just testing. So given an n, then we can stop, and then we start doing this, and then we can return the result at the end. So should I see if I can try run this and
We walk me through line by line.
or well, yeah. Okay, so right, beginning we have n, which is the number of, I guess, open or closed parentheses. That's n.
Sure.
And we use the result to keep track of our what we return, empty list so far, and then the stack, which is, oh, yeah, we need to make it. Already. I should join the stack and then append it because we're returning a list of strings. Yeah, okay.
Okay.
So we have the backtrack function where we count the open and current open and close count of the parentheses. So when we begin, we call 0 and 0. So we have 0 open and 0 close.
Sure.
And only when they add up to n times 2, 2n, can we stop and append that to our result list. And so here is when we want to make a decision. So when open is less than that.
After this runs, what happens?
Oh yeah, it's gonna keep running. So we have to stop. We have to stop here.
Okay.
All right, and then when we open the number of open parentheses less than n, that means we can still push an open, or we can start closing, depending on if we have more close than open. So we can definitely put an open parentheses. We put it, we appended, and then we can backtrack with open plus 1 because we just appended an open parentheses, but we keep the number of closed parentheses the same. And then the other case is if there are more closed parentheses than open ones, that means we can still we can append a closed parentheses.
If there's more open than closed. If there's more closed than open.
If there are more closed than open.
So if there's if there's one open.
Oh no, it's if they're more open than closed. Yeah, if they're more open than closed, then we can close, not the other one. Yeah. Close if they're more, then we can append and then close plus 1 when we do the backtrack again. And otherwise, if the number of open parentheses is already equal to n, then we can only append a close parentheses forward and then close plus 1. I think that works.
Let's try running it in like a few. Let's see. Moment of truth. Print. Oh, did it work? Let's see.
It's one. There should be five answers, and I think that works.
Yeah, it makes sense. Let's see.
Yeah, I think that one works.
Let me run What's this question? Okay, we're gonna run it and see. Like when you did the code walkthrough, it made sense. Just need to make sure. Nice, it worked. Good job.
Okay. Yeah, like for backtracking, like I get the gist of it or what I can do, but like when it comes to an actual implementation, I'm just like kind of blank out and be
Yeah.
like, what do I start with? What do I end with? And yeah,
I think this
it's
could
just
be simplified a bit more. So
okay.
like even if we just remove this, right? Let's just say if open is less than n, we can write it, right? I think this would even work. So how would this work? If open is less than n, we could push it,
Hmm.
and then like if, or but does this increase open? Oh no, if open is greater than close, I think this would still work. Let me try writing.
This could still.
It's a small simplification, but it makes the code a bit cleaner. Let's see if this works. Yeah, I just removed that and it worked. So
Okay.
it's smaller. Yeah.
Yeah, like when it comes to like during interview implementation, like I'm not confident to write super clean code.
Mm.
Like I'm following my logic around and I do like multiple if else statements.
Yeah. But I would, when doing questions, I would make sure to make it as clean as possible because if there's a bug, you need to be able to debug it, right?
Yes.
Because if you
Yeah.
have, if you aren't able to debug it, it's gonna
Hmm.
cause issues.
Right.
All right, I think we have let's get one more in. Let me look for a good question. How do you feel about that question so far?
Yeah, I think you're like it's hitting like on my weakness,
Nice.
especially these type of questions and during like the interview process
Mm-hmm.
and my approach. I think you can like I think you can already clearly tell like what I'm weaker with.
Mm-hmm. Okay, let me grab the next question. Just need to message this next guy that we're going slightly over. Started late. All right, cool. Let's get into the second portion. The second portion is more of a question that I made up myself.
Okay.
Let's see. I think I saw it somewhere. But what we're gonna be doing is we're gonna be given a grid. I'll show you what it looks like. We're gonna be given a grid.
Okay.
This. Let me just multiply this. Grid like this. Shoot. One, two, three. So we're gonna be given a grid. Some elements in the grid are gonna be -1.
Okay.
-1 means a wall. -1 equals wall. Right? 1 equals cell. 0 is just empty. Right?
Okay.
So I'm just gonna like create random walls here. Like these are the walls. There's gonna be random walls.
Okay.
right? And then there's gonna be some cells that I'm gonna cover color green, like this. Um, Essentially, what we need to do is just figure out the number of islands inside of this grid.
Number of islands. So number of cells that are islands.
Like how many islands are here? Islands
Oh,
are like connected. What I mean by
right.
islands,
Connected
yeah,
cells.
connected
Connected cells,
cells,
right?
like
Okay. So
vertically
here
and
will be one,
horizontally.
two, three, four, five,
Yeah,
six, six, six. Okay,
yeah. Like,
six.
what about this now? Are these
Uh, these are not connected, right? Because they're not adjacent. It's diagonal, so that doesn't count. So it's
yeah,
another
yeah,
new like island.
yeah. So I'll write
Okay.
up the prompt. It's like find islands in a grid with walls. Islands are cells that are adjacent. Islands are cells that are adjacent vertically and horizontally. Not right. That's my description. Find islands
Right.
in a grid with walls, and then we're gonna say one equals cell. -1 equals wall. 0 equals empty. Return
Mhm.
the number of islands.
Okay. So, what's the distinction of walls and empty? What I don't think it matters in this specific case, right?
Mm-hmm.
Because we're just looking for islands, and this, if the cells are connected, it's an island. It doesn't matter if what's next to it are empties or walls, right?
Mm-hmm.
So is it just extra information, but we don't really need to use it?
Yeah, pretty much, I guess, if you look at it like
Then
that way.
okay. So in that case, it's like finding islands, the number of islands. So I want to, I guess, loop through the entire grid, and whenever I encounter a cell, I probably want to use find all of its adjacent using something like DFS,
Mm-hmm.
and then mark the cell to empty or wall. And then when I return back, I add one to the number of islands.
You add one. Okay.
Yeah, I add one. If the grid is a cell, then I add one because then I will go through its neighbors and change everything to empty after.
Mm-hmm.
And then as I loop through, for example, here, does it show my cursor on your screen when
Yeah.
I'm
Yep. I see it.
moving? Oh, okay, okay. Yeah, so like I guess I loop through here and then I see this one, I add one to result, and then I mark this as empty, and then I loop. Oh wait, this one's up here. So yeah, if I come here, I see this, mark all of these as empty using DFS, and then I add one because it's the first one is a cell. So I add one to the result, and I get here, mark all of this as empty, add one to the result, and then the next time I get here, this is already empty, so I just keep moving forward. And then when I encounter this one, I mark it as empty and then add it to the result, and then go down, and then here, go down, and then here, and then here.
Okay. Yeah. I go
Same.
ahead and implement it. Yeah. I'm
Go
more
ahead and
just setting
implement
this
it.
up for a follow up. The quick follow
Oh,
up.
yeah,
So
yeah.
go ahead and
Okay,
implement that.
so let's see. Given a grid, so I guess. Oh God, what happened? What the heck is happening to my? Why is my D? I can't type D in here.
Try
What's
to
going
refresh.
on?
Refresh.
Let me.
Working for me.
What is going on? Okay, maybe it's an extension problem. Hold
Did
up.
you try refreshing?
Yeah, I refreshed, but it's still being weird about it. Let me.
Like it's just not typing the word D. Or...
Yeah, me. Okay, I'm just gonna refresh it again. What is happening?
Are you in drawing mode?
Oh, yeah,
Yeah.
I think I
Just
am.
leave drawing mode.
Close it and then no, that's still what the heck is happening? Let me
Try like
maybe
closing
my
out the browser and coming back. Or are you able to type in the
extension.
dot in? Were you able to type in the in your search bar, or is it just CoderPad?
Okay, I disabled an extension of my. I think it might be just messing with something.
I see.
Yeah, I had a Vim extension, a Vim commands extension. I think that's messing with the inputs. Okay. Yeah, so let's see. Given let's see, uh find islands, then given a grid. So I want to loop through every grid using DFS. So I'm gonna have to run a DFS with like row and column of some sort. And then for each row and column, let's see, for each row and column, if the grid is a cell, if it's a one, if it's a cell, then uh, we want to run DFS at DFS there and add one to our island. Once we're done, we want to just return the result. So the problem is when I run DFS, how do I check? Okay, so when I run here, I want to mark the grid as empty, as 0 now, and check the 4 directions for the directions of 1 0 -1 0 0 1 and 0 -1. Let's see. The new row is row plus row, and then column plus the new column, and if it's within the boundaries length of grid, and within the boundaries for the column, and the new grid and column is a cell, then I want to do DFS onto that new row and new column. And this doesn't have to return anything after, I believe. So I think this can work. Checks the 4 directions, and then if it's still within part of the grid, then and the grid value is 1 as a cell, then we want a DFS and we want to set it to 0. I think that works.
Wait, walk me through the code.
Yeah. So we use result to store the number of islands, And as I loop through the grid, if the grid has a 1, then equals 1, then I want to start setting it and all of its neighbors to 0, all of its neighbor ones to zeros. So I add 1 to an island, and then I call DFS to modify the grid. So I set the grid at that location to be 0, and then check the 4 directions if it's still within the grid's boundaries, and that the cell value is a 1, then I want to run a DFS to it.
I see. Okay.
So I think that's good.
Yeah. Let's run it on this case real quick. One. One. Okay, run it on this test case right here.
Okay.
How many islands should this be? 1, 2.
This one should look like 1, 2, 3, 4, 5.
Yeah.
5 islands. Right. So
Okay.
yeah, 5.
Okay, we're gonna do a slight twist, right?
Okay.
What we need to do is we have the option to convert one wall to a cell.
Okay.
Right? Wait, let me think about this. Basically, yeah, we want to convert one wall to a cell.
Mhm.
What's the biggest island what we can build? Like what's the biggest island we can create after we do this operation? Convert one wall to a cell.
Okay.
So right now the biggest island is 3. Because we have 3, 3, 1, 1, 3. So biggest island is 3. Or largest island. But we can convert one wall to a cell. And if we convert this one to a cell, we get a island of 7, right? So that's our goal. This is follow up.
Okay. Convert to the biggest island. Okay. Convert one wall. Okay, so yeah, in this case, it will be converting this wall. It will become a 7 island, an island of 7 size. Converting this one will create an island size of 5, but that's not the biggest one. So, okay. Let's see if it is possible to find the islands and set the size. The area of the island. So this will be 333. This will be 33. So
And we don't have to implement this. We can just talk about some
okay,
possible approach.
yeah.
So
Approach, yeah. So I'm thinking like if I set like this to be 333, because I know like I can find the area that's connected, and this is also 333. And then I loop through the grid to find negative ones, which are walls. And if I find a wall, I check its nearby islands and see if I can add that up. But I feel like that's going to be a problem when the adjacent, I don't know which island it's coming from. It could be from the same island. And if I try to add it up, it's going to cause problems.
yeah.
Yeah, so that I don't think that idea would work well.
Like what's the brute force?
The brute force would be um, looping through looping through everything and then set changing this as one and then run DFS at this location.
Mm-hmm.
Yeah, DFS location and find the yeah, like -1, and then DFS is gonna find the nearby uh cells and return like a 7. And then I reset this, turn it back to -1, and then keep moving forward to see the next -1, and then convert this to a 1 and then find the area.
Okay, so just try to convert every wall into a cell and see how large the island it forms.
Yeah, yeah.
Well,
But I think
yeah,
that's gonna be pretty slow, right?
yeah.
It's gonna be, yeah.
What makes it slow?
Because we'll have to find the same island multiple times. If this one is a -1, this one's also a -1, this one's also a -1, we're gonna do DFS on the same island multiple times, right? So it doesn't feel that
Mm-hmm.
we should only do a DFS when we're connecting two separate islands.
Mm-hmm.
In
But like
that,
pretend we connect them, right? Like how do we figure out
right?
the size of the island after we connect them?
Oh, wait. I think what if we use a like an ID number for each island. So when we loop through this, we know this is an island, and we set this to an ID 1 or ID 2. Start from 2. ID 2, and then this is this one is ID 3, this one's ID 4, and then this is ID 5, this is ID 6. So we use an ID and we use a hash map. The ID will link to the hash map. The hash map will contain the size of the island.
Mm-hmm.
And then each time we loop through and find a -1, find a wall, then we check its nearby 4 directions and find 2 different IDs that give us, and then go to the hash map and find the area, and that gives us the highest area.
Mm-hmm.
+1, which is the wall itself.
Mm-hmm.
I think that method would be better.
Yeah, makes a lot of sense. Cool. Thank you. How do you think you did? Like how was that
Uh,
interview?
I think the second problem is okay. Like for this, I guess I would call this like a simple grid graph traversal. This one, I did more of these, like the gates, floods, that type of problem more. So I think I'm more okay with this. But for like backtracking, that's definitely still like one of my weaker areas.
Yeah.
Like backtracking, permutation, that kind of stuff, and then I get stuck on how I can write that backtrack function.
Mm-hmm. Yeah. No, I think you did really good on the second question. Even the follow up. If you look in my
Mhm.
list, that follow up is actually pretty much
Oh,
max
is it on a? Is it at?
making a large island question, which is actually technically code hard. So, job.
Okay. Is this a part of your 75
Yeah, it's
or?
part of my 75.
Oh,
Yeah,
okay.
but I just want to build up to it.
75.
I didn't want to actually like the hard one right away.
Yeah, I
That's
didn't. I don't think I've never ever written that problem
yeah.
specifically before. So like, I think my intuition here is good. Like I try a few different approaches, and then it clicked, and found like the best way, and I can like express it. I think that's good.
Mm-hmm.
And then obviously, like actually implementation, that's a different story. Like implement it cleanly after I explain it, that's a different story, and we'll have to see.
Yeah, but yeah, I would just suggest like working on those backtracking questions because those backtracking
Mm,
it's actually boilerplate once you practice it. Just do a bunch
okay.
of backtracking problems. If you spend a couple days on it, you'll get so good at backtracking. It's pretty boilerplate, as in you you try one option and then you backtrack by popping out the stack kind of thing. Like you saw the code, it
Mm,
ended up at. I would study also the recursive tree and understand it. Make sure you
recursive
make
tree.
sure you Remember how we drew out the
Oh
recursion
yeah, yeah,
tree?
yeah, yeah, yeah. Drawing. Yeah, I think that's really helpful. I remember like whenever I watch like a backtracking problem for like neat code draws that tree, but then I always just like, what is that tree for? Does that help or?
Yeah, yeah,
So yeah, now I think it puts a clear mind and like it makes the clear decision. Like, hey, in this case, I should try this and do that. It
yeah,
like creates like a decision tree for the backtracking, which is important. Yeah.
yeah, yeah. Exactly. Yeah, it's I'll send you some of I made a couple of videos on it too, like how
Okay.
to think about the recursion tree. I made a video on
Hmm.
that. Let's see if I have it. I'll send it to you. Wait, how to get to it?
Okay.
Yeah, but yeah, shit, I hit that. Whatever. Cool. Anyways, thanks for coming out. Gonna take on the
Yeah.
next guy.
Thank you so much,
Yeah.
man.
Hope you enjoyed.
Really
All
helps.
right. See
Thank
ya.
you.
Bye.
Bye bye.
Okay, waiting for the next guy. Let's see. Hopefully he shows up. Where's this guy from? California. 182 questions. Berkeley. He lives near me, so I'm gonna go knock on his door if he doesn't show up. Legend. Paul, what was that first question you asked me yesterday? The math one? I want to ask people that. That math one where we had to do like multiply the odds and evens and stuff. No, the first one. The first one. 32. Oh, player playing game? Yeah, I never did that question before. And what was the primes one that you asked me? Yeah, what's the primes one? Got some water. Give me a sec. Paul, send me that primes one. I'll solve it real quick. I didn't even input them into LeetCode yet. Yo. Okay, check the primes one. Were these contest questions? Yo, V, what's up? Oh, okay. Oh, shoot, I didn't. Um, let's see. Advice for aspiring ML engineers. Honestly, I'm not sure. I'm not an ML engineer. So I remember this is like calculate the number of evens and evens. Let me solve this quick. So we're gonna n odds. I know there's an even more optimal way that I'm a product engineer. Paul, you already showed me how to do the optimal one. Sure. Let me just do this quick. And evens. So times odds. So that gives us, and then we could go and odds times. So how do we get the evens? We just take n divided by 2. Important math here. So the job hunter, I'll differentiate that in a second. That's a good question. Golden Line, are you there too in FB? Nice. Yeah, it's it was my first try. But I've already done a ton of leak code in practice before that. Okay, what's the difference between product engineer or an infrastructure engineer when it comes to Facebook or Meta? From what I know, product or infrastructure engineers, they work on the frameworks. So they work on actually building out the infrastructure, and that's not just like databases in the same way that you hear about infrastructure in like when we're talking about system design or infrastructure in a regular company. In a regular company, when you think of infrastructure, you think about like AWS or the servers that are running your code, the databases. That's not what infrastructure does there. What infrastructure means is you're working on the frameworks or the infrastructure that like powers our products. So what does like an infrastructure engineer could be working on the React framework, and we have a ton of other frameworks or the Flow framework. They're basically building the infrastructure for the product teams to build the products. Product engineers build out the features using that infrastructure. So we'll use React or we'll use the database essentially, or like the ORM essentially. But we kind of use those frameworks in order to build the product, and we're more focused on actually driving business value. So there's certain business metrics and things like that that we're trying to achieve, maybe revenues, maybe launches in new markets, different things like that. The product engineers focus on that, While the infrastructure engineers, they're more focused on making sure the framework is stable, introducing new things on the framework that will help product teams move fast. They're building the underlying infrastructure. We don't use that many external libraries. All the libraries are built in house. A lot of things are built in house. You won't see that much. You won't see that much. Do you have any advice for studying practice to get faster at leak code problems without having seen the problem before? I think the main thing that you want to do when you're practicing lead code is to time yourself. Otherwise, you'll just go way over time. So what I do is I would put on a timer for 20, 30 minutes. I try to solve it. If I can't solve the question, I straight up just look at the solution. Yo, V, what's up?
Yo, can you hear me?
Yeah, I can hear you. What's up? So you want to get advice on like some system design stuff?
Yeah, yeah.
Yeah, let's talk about it. What's kind of your thoughts or things that you want to know about system design?
Yeah, so I actually did like a mock interview with you, I think like a few weeks, I'm not sure how long ago it was, but it was for TikTok.
Hmm.
So
I
I,
remember.
yeah, so I ended up making it to the final round. So I
Wow.
think it's just like, yeah, dude, your help, you gave me like such good like mock interview advice and like it really helped me like in terms of like leak code and also just like interview.
Nice. What did I like? What helped? Like which part?
Yeah, I think like you kind of gave me like a little format of like when you start, you should take down notes about the problem. Also, like kind of like you were telling me about how when you're kind of going through the problem, you actually want to take some notes so that way like the interviewer at the end like they'll be able to take a look at your code because that's like all they have to see like at the end. They and you're telling me some tips like that. So I
Nice.
think those are like some of the things. But yeah, like especially like taking little notes on like the problem or like conditions, like going through each test case, breaking down the conditions. That was like pretty good. Like helped me like, because I would try to like keep thoughts in my head, but
Hmm.
like at some point you can't really like keep track of everything.
Yeah. Especially you're in the interview setting and you're stressed out. You're gonna forget
Yeah,
stuff.
yeah. So yeah, it was really good
Nice.
advice.
What were you or oh now you're in the on-site? That's crazy. That's sick.
Yeah, so I did. There was like two coding rounds. Honestly, they weren't too bad. Like the first round, I think it was like a leak code hard or something.
Mm.
And I didn't give like a fully optimal solution, but I think they passed me on. And then the second round, like he just asked me, I thought he was gonna ask me like two problems, but he just asked me like one leak code medium. It was super chill. It's like a graph problem.
Mm.
Um, but yeah, that was basically it. And I think now, uh, I was actually the reason why it took so long was I was actually interviewing for a spot, and I think that position got filled, and then they ended up team matching me to another team since I did good in the interviews, I think.
Mm.
And then my recruiter was just telling me like they might ask some system design. Um, but yeah, I'm just trying to like get like the basics down, maybe see like
Yeah.
kind of like what a problem looks like. I'm not like too familiar with like system design in general.
Yeah.
I've been using I think one of my friends gave me like Hello Interview as like one of the resources that's good
Yeah. So I
to
think
learn.
yeah. Hello Interview is a really good resource. Are you product focused or infrastructure focused? Like what's kind of the role?
I think like the role is more like just like back end.
Mm.
Uh, yeah, I think the team is might be kind of like related to like content and maybe like some moderation type thing. Um, but I think honestly, I'm not really sure what they're gonna ask. But I'm guessing like they just want to see you have like most of the fundamentals down, like some basic like services and concepts and stuff.
Yeah.
So I think that's kind of like,
Mm.
but yeah, and also like a lot of key technologies, like I'm probably gonna look into that more right now.
Yeah.
Uh,
I would say like my advice would be understand everything or don't focus on the specific technology right now because
mhm,
you can swap in and out technologies. But the first thing that you should make sure you really have a understanding on is the client server architecture. I think that's like with any even TikTok, right? What is it? It's a client server architecture. Someone has the client, which is the TikTok app, and they're making requests to the server, right? And then the
Mm.
server in the background does a lot of things, but you need to understand the flow of how that
Yeah.
goes. So understanding the client makes a request to some server. Probably it's going to hit some load balancer because there's going
Mm.
to be multiple servers behind it. It's going to hit some sort of app server that's handling the request, right? It could be a get.
Mm.
It could be like a, if it's a REST API, I can get like a get, post, put, whatever. Once it gets that request, it's probably interacting with some database to pull some data. And this is the most naive case to return that to the client, right?
Yeah.
So understanding that's a very simple. The start with very simple client server, as in you just have one client, you have one server, and it's querying one database because everything has database at this point, right?
Yeah.
And then and then think about it. What happens when we start scaling up, having way more users? That one server is gonna have way too much load, right?
Yeah.
It's just gonna be, it could be serving way too much people. So how do we scale it? Well, there's two ways. You can vertically scale or horizontally scale. Are you familiar with those two
Oh, no,
concepts?
no. I'm not too familiar with that.
Okay, so pretend we have um, TikTok, for example, and pretend we only have 10 people, so we only have one server. And then all of a sudden we go up to 100 people and we have that one server handling that. What, and now it's has to handle so many people that it starts to slow down. What are, there's pretty much two common ways to make it go faster or be able to handle that traffic as we increase the traffic. Could you think of two ways?
Yeah, so like if you have a load balancer, I was thinking like you just start up maybe like another server. I'm not sure like what the backend looks like in terms of like the app, but maybe like something that's running like the same microservices or
Yeah.
like software to handle those requests and just return the response. And I'm not sure if that counts as vertical or horizontal scaling, but
Hmm. So okay, I'll explain it quickly. There's, well, the one of the easiest things to do is you just take that server that's running your backend and just upgrading that server, adding more RAM, adding a better CPU, right? You
yeah.
basically just beef up the computer, make it stronger. That's probably the easiest way to do it. In Amazon, you can literally choose the instance and just upgrade it. Why is that? Why is that the easiest way? Because if you add more servers, you have to add coordination. Now you add a load balancer. Now you have to coordinate who's handling the request, right? So what I see is people would just, the easy thing is just vertically scale it, but there's limits to how much you could vertically scale something, right? Like you can handle TikTok on one server, but how that's gonna be the a super quantum computer, like some crazy computer that no one knows how to manage or is just requires super expensive parts, right? So that's kind of the ceiling with vertical scaling, and it does have a ceiling, and the ceiling comes pretty fast. Does that make sense? That's what's
Yeah,
called
that makes
vertical.
sense. Yeah, I didn't.
Horizontal
Yeah.
horizontal scaling. Why it's horizontal is because you're adding servers that they're gonna all the servers are gonna be the same strength usually. So that's why you could just think of like it scaling horizontally instead of like taking one server and going deeper. So it's like you're,
So
oh, go ahead.
so vertical scale. So what is sorry? So what is vertical scaling fall under then? Because like you said, I think you just said that horizontal scaling counts as like one server. You're getting like the same type of server.
Yeah,
And
horizontal
making.
scaling is you take you have one server handling all TikTok traffic, right? Maybe
Mm.
with 10 users, that's fine. Pretend that server, when it starts getting to 20 people, it starts getting slow. What we could do to horizontally scale is we just add a new server. It could be the same strength as the last one, but now we have two servers of even strength
Hmm.
handling the request.
And then you just have like a load balancer.
Exactly. The load
Okay.
balancer sits in front of it,
Okay, that makes
right?
sense.
So that's two key important concepts is how do we scale our system, especially when you're working at TikTok or all these super large companies. It's a scale problem at this point, right?
Mm. And then vertical scaling, is that like different?
Yeah. Could you explain it? What vertical? Because I just
Uh,
explained it to you, and let's see if you could reiterate.
oh, I heard horizontal. I don't think I heard vertical, but
Okay, vertical scaling is just make the computer stronger or make the server stronger.
oh, I see. So yeah, to me, I thought like for some reason I was thinking like vertical scaling is like you get multiple servers, but I guess that's horizontal scaling. Um, that makes sense. Yeah. So vertical scaling is just upgrading like the computer or being able to handle more capacity, like more load, but
Yeah,
like
exactly.
not having like more, I guess you could call them like more servers or nodes or something like that.
Yeah,
And then horizontal is just you're adding more capacity by adding more servers,
yeah,
but it requires more coordination.
yeah, exactly. It's like I don't know, vertical scaling. I don't know if you're on my stream.
Yeah, I'm on stream.
Pretend like we have like one our server, right?
Hmm.
Vertical scaling is like take this one server and as you like vertically scale it, you introduce a bigger server.
Oh,
Server is
nice.
going right versus
Yeah.
horizontal is more just like add more servers into this. So horizontal would be like adding more servers. They won't usually be that strong. Versus vertical is going down this way.
Oh,
That's
I
that's
see.
how I'd look at it. So you just add a bunch of. So the reason I I read about this and like the reason why horizontal scaling is efficient too is because at this like how what's the limit of making a bigger and bigger server? The limit is you pretty much have to build a supercomputer at that point, right? Pretend we already run Macs, right? Imagine a computer that's 5 times stronger than our current Mac. That's a super expensive computer,
Mm,
right? It requires very specialized parts, right? So that's kind of the ceiling. But what they realize is economically, if we just have a bunch of very simple servers with commodity parts and cheap parts, and we just scale them horizontally, we can handle the same load as like a big computer with a little bit more coordination. But we're just using very simple machines and very simple parts that are easily accessible.
I see. That makes sense.
Yeah. So, I mean, you could have like a super cluster of like you can horizontally scale a bunch of supercomputers if you're trying to do some crazy computing, and that's what they're doing with AI. But like these are the different leverage you could pull, right? You can take a bunch of servers and just like expand them horizontally, or you can just keep upgrading that one server and make it stronger and stronger. Like over time, it like computers get stronger and stronger anyways. But yeah, that's a very important concept to understand: the vertical and horizontal scaling. Does that make sense?
Yeah. Yeah, that makes sense. Thank you for the.
Yeah. So at some point, or you're on the streams. Okay, so what we said is there's gonna be a person. They're gonna be using like the client, which is a TikTok app. So they're gonna be making calls to your server, right? And then at some point, you're gonna have some database that they pretend they're loading up their news feed. They're gonna be fetching that from the database, right? That's data that's stored in the database. So does that make sense so far? This is the simple client server
Yeah, yeah, yeah.
architecture.
Mm,
Pretend what we want to do is we want to like we have way too many people using our app now, right? There's just like a lot of people,
yep.
right? Since they're using our app now, since so many people are using our app now, this one server is is getting too high, or it can't handle the load. How would we know it can't handle the load? What are some ways?
Um, maybe it's like it has like a log or something and it's like failing. Uh, maybe it's like showing something. some errors, or like maybe it's not returning the responses. I'm not too sure.
Yeah. Well, if this guy's load is too high, he won't even be able to tell you that his load is too high.
Oh,
I mean,
yeah,
like
that
one
makes
way
sense.
is like these clients are receiving the news feed in 5 seconds instead of milliseconds. That's one way to track it on the client side, right? You can add code on the client side to just track, but even clients they're not that reliable because people can fake the client. There can be a bad client reporting really bad latencies. But yeah, you can run health checks on the servers anyways to see utilization, like what's the CPU utilization and other things like that, right? But like
Hmm.
pretend we realize that the server is actually being like overworked. So that's
Hmm.
when what we need to do is we need to add. Let's see. We need to add more servers. Like if we want to vertically scale, right? So what does that mean? That means we have more servers handling the request. So pretend this guy was taking 100% of the load, but pretend they're being overworked, so they end up taking like 100. They're taking 20% more than they can handle. Now that we add 3 servers, we can distribute it evenly. This takes 40% of the traffic. Or like pretend there was like 120K request, something like that, and this guy can only handle 100K. So he's going 20% over. So what we can do is we can introduce 3 different servers, and then just each of them just takes 40K. And then now, what do you know what a load balancer does? Why we need it?
Yeah, I'm familiar.
What does it do?
So it takes the request and then it distributes them, like you have like round robin, or you have like some kind of scheduling.
Hmm. But why do we need a load balancer? Like what?
Um, because you kind of the load balancer acts as like two things. Like it acts as like the thing that distributes the request, but also like returns like a response.
Hmm. Okay.
So
Like why can't the client just talk to the servers?
um, because we need like a coordinator. And like I mean, at least from my understanding, I feel like you need like a coordinator, and like the servers itself. Like we can't just have all the requests go to one, and it's like trying to also maybe like answer the request while also like distributing requests or something like that.
Yeah. I think there's multiple reasons to have the load balancer.
It's also like the fact that like servers can go down, so we need uh like there's always like dynamic servers, so like some are going down, or like something can fail, so you need like the load balancer in between.
Yeah. I think one of the main things is it just like gives you a central entry point to the clients. You could have them so they you could have it so the clients know the IP addresses, but now all the clients know the IP addresses of each of your servers.
Mm.
And now they're directly like they have to maintain that. If you add a server, you need to tell the client that you have a new server. And if they're using a mobile app or something, you essentially need to like the client needs to you need to push it to the client somehow. The load balancer kind of offers a central point that you reach into, and then it can route to whatever server is available. So you kind of only need to manage one IP address. The other thing is with security, right? You want to reduce the surface area of your services, right? So pretend we have this server, we have this server, we have this server. If these are all accessible from the external internet, then they're at risk, right? Anything that's available externally is at risk because people can. You just need to make sure it has the right security patches and stuff like that. So if you have a ton of servers, you have to make sure all of those servers are at risk. They all if but with the load balancer, if you have like a gateway or API gateway, like a load balancer or whatever, Like those are you can they're almost interchangeable. There's slight difference, but what it does is it offers a just one entry point, and then these servers are actually only accessible internally by the load balancer. So now only external users have access to like one IP addresses, and they can't directly hit this because this is behind a firewall. And now these are more secure because only the load balancer is talking to them. That's one thing. I was lagging.
Yeah, that makes sense.
Yeah. Okay, but okay. Um, so yeah, that's one way. It adds one IP address. It reduces the security like surface area. You still, because what you want to do is you want to secure all of your internal services. You want to reduce all of your internal services or reduce external like people from the outside world to hit your services. Pretend I have a database right here, right? Pretend people knew the IP address of my database. I mean, they could try to hack my load balancer. They can try to hack this. They can try to hack my database directly, right?
Yeah.
So if I expose all of these to the internet, it would just have a lot of surface area. So a lot of times they just add like one entry point, like a application or like a API gateway or whatever, and just make that super secure. And then all of these that talk internally talk inside some internal network, so that nobody from the outside world could ever reach our database. They have to go through, like they have to get into our internal server, and they have to like talk through our systems just to get to our database. That's just like that's for a security reason.
Sounds good.
Okay, and when it comes to vertically and horizontally scaling things, you can do that on every layer. So pretend we upgraded our servers now, right? Now we have multiple people talking to this. What is the bottleneck now in our system?
It's gonna be the database. The database, like maybe like the speed of reading it or handling requests or something like that.
Exactly, because at the end of the day, this database is still a server. It gets queries, it executes the queries, and returns it. So you could actually horizontally or vertically scale this layer as well.
Yeah, that makes sense. So you just vertically maybe scale the database so it handles more queries or have like multiple copies of that database.
Exactly. One very simple way to do this is have one write replica and one read replica. As in everyone will just read, or whenever you need to write data, you write to one database. Because the problem when you horizontally scale the database is now a consistency problem, right? Like pretend I write data to this one, and all of these need to be synced. We have a consistency problem. Pretend I write to my bank account. I add $50 and I read from this guy, because maybe this guy is getting overworked, right? I have $50 here and I read zero. I'll think I only have $0 because it hasn't propagated to the other servers yet. So when it comes to does that make sense or no?
Yeah, that makes sense. So basically it's kind of like the idea where like there's like you want consistency, so sometimes they might ask you like you might have to clarify like are you looking for like availability or consistency or like what you ask the interviewer or like whoever's like in charge like what do they want, and in this case like we want transactions to go through in the database, and we want like all the database servers to be like in sync, so we want that consistency.
Yeah, that's the CAP theorem. Pretty much CAP theorem. I don't know if I spelled that wrong. That's the CAP theorem. Like, yeah, you should look into that. I think my main advice for you too when you're doing this is focus on the. So when you start the interview, you're gonna have to walk through the multiple steps, right? You're gonna have to do requirements gathering. This is similar to leak code when you're just trying to you're asking clarifying questions,
Mm-hmm.
right? So I would say have a good process in like be systematic with how you solve the questions. So the way that I like to do it is you do the requirements gathering. That helps you figure out like what is this system, what do we actually need to achieve in this interview. For example, if they tell you design Uber is such a large system, no one will expect you to solve that in just the hour. So you need to do requirements gathering to like cut down on all of the excess stuff and just get to the core of what they want to know. And that's a skill with anything in software, because you could just build anything, but being able to prioritize and figure out what has the most impact is very important. So that's the first part, requirements gathering. Does it make sense?
Yeah, that makes sense.
After you do requirements gathering, it all depends on, like, the advice I got before is it all really depends on how you think about stuff. Like some people are front end engineers, so they start thinking about the front end first, and then from the front end they start thinking about how the front end is gonna look, and then once they understand the UI, they start figuring out the database and or the server that they're gonna hit, and then once they figure out like the APIs, they figure out like how it's gonna be stored in the data, right? So some people think about it that way. Some people are more back-end engineering, so when they think about a problem, they start automatically thinking about the database tables, and then they start working on the APIs, and then they finally look at the front end, right? So it all really depends on how you do it, or like how your mind works. But for me, I like to start with, um, honestly, I like to think about the front end just a little bit. So I like to so someone says design me a newsfeed. I like to visualize that newsfeed as a user using that newsfeed. So I could just see like, okay, once I load the newsfeed, what does it look like? What data do I need? And then what happens? And then once I figure out what the front end is like, maybe I'll draw a simple, okay, I simply just do like this, like, oh, we have a front end, and then pretend we have a newsfeed. So I'm like, okay, we need post right here. This is it. I draw a simple one like that. I don't get too deep into it. I say once we have the front end, I start thinking about the APIs that we need to hit. So from the front end, we need to get post. I start to think, oh, we need post endpoint, things like that. So I start thinking about the APIs that we need to hit. And once I figure out the APIs that we need to hit, like for example, we need to hit post, I start to think about the data model. Like what are the things in the database that we need to store in order to fetch post? We'll probably have a post database. Right? I just talk about the high level objects there, maybe like a users. So we're friends, so we can grab like posts for specific friends or whatever. So we start thinking about the data model. That gives me a high overview of, okay, we have this front end, it hits this API and it grabs the data. That's kind of what I showed right here, the very basic client server architecture. That will suffice like a lot of the functional requirements. So when you have requirements gathering, there's going to be two portions. Are you familiar with the functional and non-functional? I think you're mute. You're muted.
Oh, sorry. Yeah, sorry. I think I muted myself. Yeah. So functional is kind of like you're kind of looking at like what's like the function of like the app or a service that you're running.
Yeah.
So kind of like, okay, how should this work? What should when the user does this, like what should it return? And then non-functional is more like what do we want in terms of like the service? Like what do we want the user, or how like kind of like not the function of the service or app, or but more like what's going on in the background, like how do we want to work? Um, and that can be like, okay, how many users are we gonna be handling? Um, and in a database, like, do we want like availability or consistency?
Yeah.
Like, are we trying to like, what are the priorities basically,
Yeah.
and some requirements?
Yeah. I would think, yeah, that's exactly right. Like functional is what does your app do? Or what are the features that make your thing functional? After that, the non-functional is more just related to the user experience. So for example, the newsfeed app. What are the functional requirements? When a user can see all of the posts in chronological order, reverse chronological order of like their friends that they followed, right? That's a feature, a function that your system has. A non-functional requirement would be they need to be able to see that newsfeed in 100 milliseconds, right? It's kind of like a user experience kind of thing. Like, that makes sense?
Yeah, that makes sense.
So the reason I'm saying that is you should try to make sure you hit all of the non-functional requirements first. For example, if you build a system that's scalable but it doesn't even return the newsfeed, what's the point? You know what I mean? Like,
Yeah.
so you'll see a lot of people, they'll just start drawing crazy diagrams and caching and indexing, and they're trying to hit
Yeah,
these non-functional requirements without ever hitting the functional requirements. That's
I
that's
see.
the main mistake I see. So especially if you're at entry level, all they really care is that you satisfy the functional requirements. So if they're telling you build a news feed, build a messenger, for build a messenger, you built a system where it doesn't need to be scalable. It could only work for 5 people, but you built a system where someone can send messages and receive them on the other end, right? That's the functional requirement. The
Okay.
non-functional would be like, okay, we have like 1,000 or 100,000 people using it. We want it to be fast. We don't want people to lose their data. We want it to be secure. Like, you should focus first on the functional requirements and making sure that your system first does what you need to do, and then after that, you have like the scaffolding. You could just start scaling it up. Be like, oh, my newsfeed is slow. How can I update my very naive system so that it could serve the newsfeed faster? And just focus on very specific stuff. That's the more systematic way to do it, I would say.
I see. So kind of like starting with like a base and then adding on top of it once you
Yeah,
get like the main main idea
exactly,
down.
exactly. Like if you're a more senior candidate, maybe this is not the best advice because you'll waste too much time building a super naive solution. Maybe they think you only know the naive solution. But you said you're still a new, like
Yeah,
you're
new grad.
so yeah, even with new grads, a lot of the times when I was doing interviews, they're just telling me like, did this person meet the functional requirements? Even and what and pretty much if they reach the functional requirements and maybe some non-functional, of course it needs to be a little bit scalable, a little bit fault tolerance. Like if it's just one server, it's not going to be a really good system. But like, just my advice would just be iron out the functional requirements. Talk about a few non-functional requirements, but iron out the functional requirements and make sure that your API data model and then your high level design, which is like the drawing, satisfies the functional requirements. Make sure you do that first before handling the non-functional.
Sounds good.
Yeah. Any questions? I think that's a lot
Uh,
of info already for me.
yeah, I think that was a good amount of info. Do you think like maybe when you're designing like when you're designing something, you should maybe focus on like vertical scaling versus like horizontal? Like you said, maybe like one server is not like the best idea.
Honestly, everything is trade-offs. What really differentiates senior candidates with more junior is understanding the trade-offs with the different stuff. So, what's the trade-off of horizontally scaling a database? Right now, it's the coordination part. Now it's like how are you gonna shard the data between the different databases? It's not like one way is better than the other. So when you would interview people, you would try to understand if they understand the trade-offs between horizontal and vertical scaling.
I see. So maybe like you could talk about the two options and then go about the trade-offs, and then from there just be like, but I think maybe this is the better option for these reasons, and then
Exactly.
and
It
then
it depends. Like pretend we have TikTok, right? And it's 1,000 users, and now our database, like our data, or sorry, now our application server can only handle 1,000 users. But if we increase the CPU and RAM by just a little bit, it can now host 50,000 users. And the only downside to doing that is we just have to shut it down for a second and then and then like spin up a new instance on AWS that's bigger. Maybe we would just take the site down for like an hour. All of a sudden we have like room to grow to 50,000, and it only took like a day to do, right? Is that like you start to think of like the different options and the trade-offs. The trade-offs like how much time is it going to take to implement it, and then like what's the gain? Because if we think of horizontally scaling, we realize that there's so much things we need to change to horizontally scale it. Like we need to introduce these new load balancers, this like that. We realize that it's probably easier to vertically scale. Then we should probably go to that. So that's the kind of thing that you need to think about. I don't know if I explained that well.
No, no, I think you explained it well. I never even thought about the trade-offs versus like when you have like horizontal scaling versus vertical. I always thought like vertical is so much better, but I'm realizing now it introduces like more complexity, and that might not always be the best thing depending on like what you're looking for.
Yeah, if you're looking to, yeah, it really all depend. Everybody's situation is different, right? Like I've been at companies where it was just easier to just like increase the size of the server and then just call it a day and work on other stuff. There's other business needs. Because once we have to horizontally scale it, then you need to a lot of times add some application layer logic to be able to like read between the different instances, and then you need to worry about consistency and all these other stuff. So it all really depends on your system at the end of the day.
That makes sense.
Yeah. And I'm only saying this because, well, that's one specific example, right? There's trade-offs in every part of the system. And a lot of times you'll learn it from experience, but you should also think about it because interviews will also like dig into it. For example, like when I was doing one at DoorDash, I was talking about using like server timestamps versus non-server timestamp, and then they're really trying to dig into what's the trade-offs between using the different timestamp formats and like different little things. They'll be like they'll always want you to come up with multiple solutions or be able to come up with different like propose different solutions, um, multiple different ways to solve the problem, and then be able to tell you the trade-offs. Maybe not for new grad, but definitely for like the senior
Mm,
candidates. So I would just like, but I wouldn't train to just be new grad. I would train to be as good to pass the senior bar, and then that will just make it so that you could pass the new grad bar easily.
yeah, it makes sense. Yeah, I think I've heard of that before. Like I've had friends and like they're always grilling you on some small detail or like wanting to see what's the trade-off and like if you especially if you don't know multiple approaches to something like they can tell you're inexperienced.
Yeah, exactly. Yeah, that's the main thing with system design. There's so much different ways to do it, but
Hmm.
and like the most junior thing they do is be like, this is the best way. Always just horizontally scale. It's like that's not the case. You have to factor in business needs. You need to factor in like complexity. In
uh,
real life, you need to factor in also the skill set of your teams. Like if no one
oh shoot.
understands that. Like there's so much different factors. But yeah, that's just stuff to bring up.
Yeah. Yeah, that all makes a lot of sense. And so like do you think for just for like brushing up, so like in terms of like maybe like a uh kind of like a road path for like studying, do you think it's better to like I think I see like especially on a Hello Interview there's like a section where you can just learn the key technologies and stuff, common patterns. Um and then there's also like a lot of there's core concepts and then there's like question breakdowns I see. So I'm thinking I'm just gonna probably look into like the problems they have and just try to do a few.
Yeah, just learn by doing. You could read all you want about like what we said right there, but once you try it, literally do this. Take a blank Excalidraw, and then right in the middle of it, just write, be like design a newsfeed, and then see where you get. Like go in the middle of a whiteboard and design a newsfeed all the way, and spend time yourself. Spend an hour and see where you get. Then compare yourself with the answer, and then once you compare yourself with the answer, you realize where all your gaps are.
Okay,
So it's
sounds
it's
good.
it's hard to do it too. Like it's hard to push yourself to like you see design and use feature like where do I start? You know what I mean?
Yeah,
It's hard, but it's what it takes to get good. And you do a few, and you'll be good.
sounds good.
Yeah.
And I mean, I think I've done a few I think I've done a good amount of behaviorals, but like, you have any tips for that? I think probably just making a few stories and
Yeah,
I think it
definitely.
should be fine.
What you do is just write a document with all of the common behavioral
Mm,
questions. What
mm,
is your biggest weakness? When is the time you had a disagreement with a coworker? When is a time when you had multiple priorities and or you had way too much work, more than you could handle in a day? Different common ones you could GPT it. But for what I would do is for all of the common behavioral questions, I would write a situation, or I would just write a star format for every single one of those, and it doesn't need to be a full out answer. I would just say this is the situation. So when is the time you had a disagreement, and then I would just be like, okay, this is a situation when I was working on a translations project, and then like when is the time when I had too many things to do than I had time for. Maybe it was during midterm season, right? So I just like, for all of those, I kind of remember a situation, and then when it comes up in the interview, I could automatically remember that situation. Because one thing that happened to me once is that I was asked a question is like, how good are you with security? Like security is very important here at the company, right? And then I didn't have an answer, and I was just like, oh, I just really value security. I think security is important. I mean, if you get hacked, that's a terrible that's a very terrible thing, right? Like because I couldn't come up with it in the spot. But actually, before that, I was literally working on the authentication features, like the authentication framework at my company. So I was helping build out like role based access control. I was helping out build out the permission based access control. So I was really understanding how authentication works and stuff like that. So I could have gave a way better example if I just remembered the situation when I did something related to security, instead of like trying to on the fly come up with stuff. That's why I always suggest people just list out a bunch of behavioral questions and figure out a situation when you were put in a situation where like you had to like exercise that behavioral muscle kind of thing. I don't know if that
sounds
makes
good.
sense. Yeah.
Makes sense. Yeah, I think for me, like personally, I think I'm pretty good at like just coming up with stuff on the spot. But I think I also have done like I think I did a doc once. Like it was like for I was trying to find internships. But yeah, I'll do that for sure.
Yeah. I'm good with coming up with stuff too, but you want to come up with the best stuff possible. You
Yeah,
know what I mean?
yeah.
Like it's competitive. So
Yeah,
if
you
you
kind
have
of want to like outshine
yeah,
anyone else
exactly.
who's like being considered, for example.
Exactly. Like I said, like I came up with that security thing. It's not like I just choked. I came up with a random thing, but my answer could have been like 10 times better if I talked about the authentication features that I built. You know what I mean? Like, and I just for some reason I blanked on that specific question. And a lot of the interview I didn't blank on, but like still I could have killed it. You just want to be prepared, honestly.
Yeah, just fill in all the gaps.
Yeah,
Make
you
sure you're
don't
good.
want, with how competitive the market is, you don't want to leave no stone unturned. You want to be prepared for every part of the interview when it comes behavioral, when it comes to system design, and when it comes to studying algorithms.
Yeah, I was doing this OA recently, and I I think I fully solved it, but I was using like a hash map instead of like an array or something because I was just throwing like the index value pairs, and I was getting like memory limit exceeded in hidden tests. I was like, what the hell is this? And then I realized that like uh I could have used like a set for something and used like arrays and it would have decreased the memory. And just like these small things, like you gotta fill in all the gaps.
Hmm.
It's competitive.
Yeah, yeah. I'm gonna hop on with the next guy. Thanks for
Sounds
hopping
good.
on. Yeah, hopefully
Yeah,
that was
thank you.
useful.
Yeah, it was really useful. Thank you for all the help.
Yeah.
Appreciate it.
Let me know when you go study, and we can always just hop on and just chat. I love talking about the system design stuff. That stuff is
Sounds
fun.
good.
All right.
Appreciate it. Take
See ya.
care. Bye.
Okay, who's next? Yo, Golden Line was good.
Hello.
How you doing?
Good. How about you?
Pretty good, pretty good. Thanks for hopping on. Let me grab my water, some water real quick. Give me 30 seconds. I'll be right back.
Yep. No worries.
Let me see. Test, test. Okay. I'm gonna send you the link to the coder pad.
Okay.
Let's see. 475 South Carolina. 475 questions. Self-employed game dev. Sick. Okay. Okay, wait. Let me grab my water. I'll be right back.
All right.
Let me start up this. Is it lagging? Can you hear me?
Yeah.
Nice. Cool. I'm gonna start up a video. Hey everyone. So today we have a self-employed game developer from South Carolina hopping in and doing a leak code coding interview. Um, yeah. So could give a quick background on yourself? Like that's
Yeah.
cool.
Sure.
You do game development.
Yeah. So I previously worked at Amazon, and then
Nice.
I worked as or I worked at a startup for a year, and I'd always done it as a hobby for like the past 7 years or so. Um, Currently working on my second Steam game, but I wanted to get back into Fang or some normal job, so back to doing leak code.
So you graduated 6 7 years ago. You're pretty close.
4 years ago.
Okay, nice, nice. Which school did you go to?
University of South Carolina.
Nice, nice. They have a really good basketball team for women's. Um,
Yeah.
let's see. What kind of frameworks do you build on? Do you use Unity or like what's your game? What game engine? Or you said
I
Steam?
use Godot.
What's it called?
Godot. It's like
Oh, I see, I
Godot.
see.
Yeah.
Nice. And how long have you been outside of working from Amazon? Like when did you leave working the corporate world?
Around 2 years ago.
I see.
Or actually, 1.5. Yeah.
Yeah. Why do you want to get back into it?
Game dev. Uh, you got to be like 1 in a million to get to the top, but
Yeah.
I wouldn't be opposed to making another game. But
Yeah, you could do it on the side too. Right?
yeah, but I guess it's kind of doing the same stuff for hobby versus work. It's a lot more draining. But
Yeah. Yeah. Cool. So you got into Amazon before, right? They asked
yes.
for some pretty hard interview questions. So you're
Uh,
pretty good then, I guess. Like from what I know, they asked some pretty hard questions.
yeah, it was I mean, it was like one of my first major jobs out of college,
Yeah.
so I think they might have gone kind of easy on me. But
Okay, cool. We're gonna start off with the first question then. Let's get straight into it. So we have an interactive code editor here. This is the, you can run the code as much time as we want. We're gonna prioritize working code. Yeah, you can see you've worked with these before, but I'm gonna tell you the first question. I'm gonna draft it out. This is a question that I did before, been asked this before, so I just want to I'll give it to you. So we're essentially gonna be given an array like this. Let's just assume we have an array. The array is gonna be mostly zeros. The array is gonna be mostly zeros, but there's gonna be 2 ones in it. There's gonna be 2 ones in it, like a 1 and a 1. Our job is to draw a straight line between the ones. So for example, for this, it would probably look something like 1, 1, 1, 1.
okay, interesting.
Right.
So we have a 2D array, and we just have to line up from some starting point to an ending one, kind of as best we can. Should
In
we?
a straight line, it should be a straight line.
Okay.
And I'll tell you if that's considered a straight. When you do it, I'll tell you if it's a straight if that's a straight line. But we're gonna try to. All we need to do is connect. We're gonna be given 2 ones, and we need to connect a straight line to them. Pretend if the ones were just right here. I'll give you multiple cases. If the ones were right here, it's just a straight one. I mean that's obvious case, right?
Yeah, makes sense.
This case, pretend we had a 1 here. Sorry, 0. What would that be? Probably like 1, 1, something like that.
Okay. So question, would this be valid for that one if we did like 1 like that instead?
No, because it's like it's 1, 1, and then it just goes up. It needs to progress towards the other one evenly.
Okay, so
Like for
I
example,
guess that means
if we just go up right here, 1. Like this is not a valid path right there. This is invalid.
okay. So back with this example then, it's always going to be symmetric, basically.
Yeah, exactly. It's gonna be symmetric.
Okay. So one way we could go about doing this, starting from I guess it doesn't matter, just starting from one of the points, we could do a BFS, where we do like or using the 8 surrounding directions, compared to like the cardinal adjacents, like up, down, left, and right. So we could do that and just take basically the shortest path. One thing to watch out for, if we did that, we might end up in a situation like this, where we keep going to the right and then we go diagonally up, but we said that's not valid. Let's see. So another approach we could do is we find the midpoint between them. So if we were using this example again, then the quote-unquote midpoint, it's in between a lot of stuff here. It's like the center of these 4 cells. So we could just round down basically. So since it would be between all 4 of these, we just reach the like one of those corners basically. So that'd be this one, and whatever the difference that we took there was. So in this case, the difference was moving 1 to the right on the x direction. Then we just mirror that, mirror it along that center point. That's maybe a little complicated to do, but here, I'll write that as one.
Yeah, write it down.
Yeah. So find midpoint. Let's see. Is there any other way we could do this? Are there any other clarifying questions? So here, I'll make a slightly larger example. Maybe we can.
Yeah, let's just align on what it means to, because it's not that clear. Or I just want to make sure it's clear that we know what it means. Or like what, so one between this one would be like this, right? Oh, wait. Let's see. Yeah. Or you make the example, and I'll verify if I think that's a straight line.
Okay.
If that counts. Yeah.
Yeah. So you're saying this one is valid?
It would be. I think this would be like this.
Okay. So yeah, it does have to be symmetric. So let me.
Yeah, it needs to be symmetric.
Yeah. Okay, so yeah, maybe if it's always symmetric, then yeah, maybe this second approach, like this BFS one, has some issues, like it has many edge cases, whereas this one, it's a little annoying to implement, but we could maybe do that.
What do you
And
mean?
it's like,
how would we calculate the midpoint?
okay, so we just take their coordinates, like, yeah, so in this example, you just get the coordinates of the one that was up here. So yeah, I'm going to make this blank again, or rather take out these two. So yeah, we can take the coordinate of this one, which doing the y-x ordering is 2, 1, and the other one is at 1, 3. So the midpoint there is like 1.5 and 2. So yeah, again, if we round down, let me write that. Then it's like 1, 2. So that would fill in this spot here. And from there, we can draw a straight line. Here, I think maybe, is there another example that would be used here to make any patterns stand out? If it was something like this, where it doesn't perfectly line up, or yeah, we'll do this one. So in this one, the midpoint, or like the line that we'd have to draw, is this, right?
Where is this?
It's the bottommost array. So like, yeah, we have to change these ones, or would we also have to change this here? So like, is it a thick line or is it like thin?
I think it's this line right here, the one that you have there.
Okay. Yeah, here, if we stretch this out more, so if it was like that, then we can again go for the midpoint. So yeah, I guess maybe
Let's
this
see.
doesn't quite help, or it's still
Okay, we
not
could
as
draw a line
straightforward.
here. No, I think.
Oh.
Okay, pretend it's this one right here. Yeah. It'd be something like.
Oh, okay, so in that case we can always just move closer on the coordinate that's like greater distance away. It's like if we're farther away on the x, then we move in the x direction.
No,
If we're farther away on the
Loki, this
y.
question's kind of stupid. I got asked this once. But like it's a weird trick to do it. It's well, you kind of just need to figure out the distance, because it's hard to figure out what we're doing here. But I think the main solution is just figuring out like the distance, or the distance between, like, how do you calculate the distance between two, or like a straight line between the two ones, right? Like 2 points. If this wasn't the thing that complicates it is this, it's an array, right? Pretend I had like a Cartesian plane, and I had to calculate a line, or I have to draw a line directly between the two.
I mean, yeah, I think like does this approach work though of just always move on the coordinate direction that's like farther away? It's like if you're farther away, in this case, we start farther away on the y direction. That's why we move up first.
That's why we move up first.
Yeah, so like starting from here, or here, the corner coordinates, or like the start and end point. This one is at 7, 1, and the one up here
Look, I think, yeah.
is at 1, 3. So
What we do.
so since 7 minus 1, like the absolute values here, the difference there is 6. So we need, that's why we know to move up on the, or move in the y direction.
Mm-hmm. Let me just switch up the question, actually.
Okay.
It's not a good question. This is not gonna. I was trying something out. I got asked that at like this one AI startup company, but I couldn't reproduce the question. Like, I'm not giving you a good example though. That's why. Like, you're giving me 2 different points, and I'm like, I can't figure out. Let's see.
It's a pretty ad hoc question.
Yeah.
Like
I'm just pick from my list. I need to. I want to come up with that one because that was a good one. But I need to iron out the kinks on that question. There's a lot of good ones that I have in my head that I got asked. I just need to actually, but they're not on LeetCode.
Oh.
How are you with the different? Are you good with arrays?
Yeah.
What about backtracking and stuff?
All right, so like I practiced like 1 or 2 from every category like today.
Nice to prepare. Nice. Is that how you usually practice?
When I'm trying to prep for interviews, yeah.
Mm-hmm.
And it sounds like both you and I do LeetCode for fun, so.
Let me get a good one. Were you in my stream yesterday?
Yeah.
Okay, we'll do this one. This will be the first question. I'm gonna cut out that other stupid question.
Okay.
We'll do, yeah. This one's might be a bit tricky, so we'll try to just spend most of the time on this question. If we finish it, we can move on to the next one. Let me know.
Okay.
Oh, I think you're highlighting. Or is that me? Oh.
Not me. I think, is there another person still? Like,
No, wait,
there's still another cursor in here.
So, Yeah, Alan, you're still in. Okay. Let's move to a new pad.
Okay.
Delete this. Sorry about
Yeah.
that first question. We're gonna do this one's gonna be good for sure. Okay, this is the main question we're gonna work on for this coding interview. So we're pretty much given an array of routes representing bus routes, where routes I is a bus route that has the ith bus repeating forever. So for example, this is the example right here, example 1. The input is this. We're going to be given a list of routes. Let's say this is bus 0 and this is bus 1 because that's the index. So for example, bus 0 follows these routes. It goes from station 1 to station 2 to station 7. Bus 1, and it just keeps repeating. From 7 it goes to 1. Right?
Makes
keeps
sense.
repeating that forever. And then same thing with 3, 6, 7. So we're going to be given start. We'll start at a bus stop, like at a specific bus stop. So we're going to start at station 1. Our goal is to figure out from station 1, can we get to station 6?
Okay.
And we need to figure out the least number of buses that we can take to get there. So if we could just stay on the same bus, we can hop on one bus and get there. That's optimal. If we need to make a switch, that's fine. But we want to minimize the amount of buses we need to take in order to get to the destination. That's my explanation. Let me know if you have questions.
Okay. So yeah, we started at 1. We're trying to get to 6. So let me just read this again. So okay, so yeah, because 7 is in both routes, then you can basically change which route you're on through that. And then yeah, so that makes sense because we're starting from 1. Wait, take the first bus to. Wait, wasn't the. I thought the order was like bus 1 goes to 2 and 2 goes to 7 and 7 goes to 1.
These are stations, not buses. So bus 0 passes by these stations.
Okay, so yeah, it's the number of buses we have to take, not
Not the
Okay.
amount of stations.
got it.
So the first strategy is take the first bus, which is bus 0, and ride it to 7. Once you ride it to 7, you can hop on bus 1 and take bus 1 to stop 6.
Okay. Let me get some clarification here.
Sure.
So, are all of the routes the same length? Like, could this have like 8 and 9 here, but this one still has only length 3? Like, is this allowed?
Yeah, it's allowed. The
Okay.
amount of stops that a bus will stop at are different. Some buses will have a ton of stops. Some might have only a few.
Okay. All right, so yeah, we're given the bus source that we start on, or no, the station, right? It's like this
Yeah.
1 refers to
Yeah.
wait.
Like for example, we can even have like a bus 2 here, and it could start at 1, but then it just goes to 10, then goes to 1, over and over. It's like we could get on here too if we want. On bus 2. I think you're muted. Or,
Oh,
does it make sense or no?
yeah, I think that was a slightly different question you're answering. Like that was from the earlier one, but if we're like when we're at source 1, is this bus 1?
No, it's just station 1. So that
Okay,
means you could
yeah.
enter bus 2 or bus 0.
Okay, yeah, that makes sense. Okay, so some approaches that we could do for this. We can do a BFS, just to find the number of switches they have to do. It's not a totally straightforward BFS because for at station 1, let's just say I'm trying to get to location 9. It doesn't really matter that it goes from 1 to 2 to 7 to 8 to 9. It's like connected components, basically. So it's we can just map them all to the same group. So it's like we just have to do a BFS like between different buses, basically, like between the groups themselves, and not. It doesn't matter within one group, like how many stops there is between them. So connected components, we group each route, or yeah, to one group, then do a BFS. So that's one approach we could do.
Group each one. Okay, keep continue.
What was that?
Well, continue. I was clarifying, or I was just thinking about something.
Yeah. Any other approach? Let's see. I mean, you could do a DFS, but since we want the shortest path, we want to do a BFS, like breadth first search. Yeah, I think I don't immediately see any other way to do this.
Could you just clarify and group each route into group? Like, what data structure are we gonna store these groups in, and then like how are we gonna run the final query to be like, or run the final BFS on that data structure?
Sure. So we could say we could use a dictionary if we want, or a set of some kind. So like the dictionary has a key which is the bus number, and the value is a set of the like the stops that it has. So that the bus goes to.
Sure.
And from there, so if we're starting in this example at source 1, so we're here and we're trying to get to 6, then we can just loop through, or we can build a graph here and see like the shortest path from this group to each other node. So we do like, I guess there's only one like query for each of these, so we don't really have to do a pre-calculation and like cache everything. But I mean, we could do that. Does it make sense what I mean by that?
What do you mean?
So we can initially do like, we start from this group and we just save the shortest path to each other node. I guess yeah, we don't have to like calculate for every single node the shortest path to every other node. We just care about the source and the target. And this is a single query problem. Like we're only asked about this one. If we were asked about like find the source from here to here, here to here, here to here, that's a huge list, then we'd want to do that pre-calculation. But since it's only this one, we can just like, we don't have to save all the results. Just we start here, and then once we see the target, since we're doing a BFS, that should be the shortest path to get there.
So when we're performing the BFS, what's going to be in our queue essentially?
Yeah. So we have all of the we'll start with all the routes that are in our same source. So we could have each of these go to a map. Like for this example, we would make this into a set. Oops. And to know which group it's in, let's see. There is I forget what this is called. I did this in a problem recently. You just make the lowest node be the root or the master of this group. But we don't have to do that. We can maybe use some more memory here if we wanted. Basically with that.
Because here, what I'm sets of stops that the bus goes to. Isn't this just this? This bus is telling you, it's just a list. But if we just convert to a set, wouldn't just we already have this data. Just bus num to index 0 to the set of stops it hits.
Yeah. So maybe this is wrong. It should be when I look up 8, I know all of the buses that it's connected to are in one step. So let's see. Yeah, if I look up 1, then I should be able to get bus 0 and bus 2. Yes, because it's 0 steps from that. I'd have to think about this for a second. Yeah, so we're going from the queue would have the starting station, and from there you want to start the queue with all of these are 0 steps away, quote unquote. So yeah, so we just store the number of steps away that each one is. So maybe we can do that whole pre-calculation. So this would be if we're storing the number of steps away, and this would be.
This is your queue you're doing?
Yeah.
Okay.
Oops. It would be like this and so on for all of these.
Okay, so all of these are 0 away.
Yeah, because we're starting at 1, and then we also have to do that down here. So to know that 1 is connected down here, we need to invert this. We should be going from the station number to the I guess that is what this. Or yeah, you want the connected component, so we need to know that 1 is connected to 10, and 1 is also connected to all of these. So we could probably do an optimization later for that, but yeah, we can just have a separate grouping or not exactly pointer type stuff, but that's the idea since these groups aren't changing. Like 1 would map to the group like 1, 2, 7, 8, 9, and 10 as well. And then it's the same for all of these. Like even 10 maps to that same thing. And same with all these numbers. They're all mapping to the same group.
1 maps to 1, 2, 7, 8, 9, and 10.
Yeah, because of this down here. Like this was added later in this example,
Yeah.
but
these are all connected components, right? This is connected to this 1 through 7. So wouldn't this one just have all of them? This one.
So this was checking where the 1 was connected to.
Oh,
You're saying for 3.
1 is connected to just 10, or
No, it's connected to all like 1,
Okay,
2,
directly?
7. 8. Yeah.
okay.
Does that make sense?
Yeah.
Or
That makes more sense. I'm just wondering. Yeah.
and then 3 would be connected to not that group, just 6 and 7. And it's like 2 is connected to this whole group again. So there's some repeated information here, like we're repeating this entire set here. So that's when we can like reduce the group, which
But with that information, how do we like start like planning out or traversing towards the stop that we need to get to? Like the
yeah,
flat one.
so if we're starting at 1, then we put all of this on the queue, and they're all 0 distance away. And from each of those spots, so like let's say we're starting at 1, let's see, we would mark all of the connected ones as seen. So I guess maybe we don't need all of that on the queue to start. Yeah, I'm gonna take that out. So yeah, the queue would actually start with this.
1 and 0. Okay, and then
yeah, it's the station number of steps that we've taken so far. And then so we go, like we would put all of these on the queue after that. So each of these gets added. We're missing the 10 at the end. But it would all be distance of 1 away. Well, that's still not true. If it's not already seen, then we can say the distance. Oh, yeah, this is.
because
Yeah, if
we want to
sorry,
do a
Rose.
BFS, right? We want to do some sort of BFS, like you mentioned,
Yeah.
because we're trying to find the shortest path between 2 buses.
Yeah, so yeah, I think we can just track all of the like when we visit 1, we add everything in that connected component to the scene group. So like when visiting, when visiting a station, to the scene set, and whenever we would loop through everything in our connected components like that we haven't looped through yet. And once we do that, like once we're in a connecting component where we haven't seen those before, we add everything into the queue from that connected component with the step size of our current step plus 1.
Is the plan to like, whenever we see the station, when we dequeue an element and that's the station, we return like the amount of steps it took there?
Yes.
Okay, let me see. But what if pretend, okay, we could take this one bus, right? Take 7 and get off at 6. What if we had, this is bus, let's see, 4, 5. We're gonna or sorry. One, two. Bus. Pretend we had bus here and it was bus 2, 6, 7. We had 7, 6 here. Or sorry, or 2 to 5. 5 to 3. Right. So we push all these into the queue, right? With 0. Then we push bus 1, 2, and 5 with 1. Since these were in the queue first, we'd probably push these into the queue next, right after. And then, essentially, I think with that solution, we would end up going from bus 0 to bus 1 to bus 2 to bus 3. If we're gonna push the stations onto the queue. Does that make sense?
Wait, you're saying if we start at 1,
Yeah, like
Man.
run your test on this now. Like this example. This is a harder example.
okay, so yeah, we're starting at 1, and or rather, bus 1 maps to all of these still, which yeah, and bus 2 maps to that same group minus the 10,
Wait, bus 2, Matt?
or station, sorry. Yeah,
What about the
here.
5?
Yeah, 5. Yeah, and then same with 3. Yeah, here, this is station. Here. To, yes, this is like, maybe I'm mixing up the terms here. It's the station to, connected stations.
To connected stations. I see.
Like
if we started it at that station, these are the connected.
yeah, they're quote unquote 0 steps away. Like I don't have to
Okay.
transfer.
Okay.
Or yeah, I don't have to change bus. Oh, I see. Wait, I think I see what you're saying. So like, yeah, if I was trying to go from 1 to 10, or
1 to 6 still. There's 2 paths now. There's you go here and then you go here and then you go here. Or you can go 1 to 2 to 5
yeah,
to 3 then here.
So like, as we search the places, like through the BFS, if we've seen a spot, if we've been somewhere in more steps, like we always just set the amount of steps that it took to get somewhere to the minimum of its current value. So I guess we are still like exploring the whole graph in that case, which maybe isn't the best thing. No. Does that make sense, or should I like kind of draw out what I mean?
Okay, I think if we try to BFS based on stations, it's not going to work. Because of like what I mentioned there, Here, let's go in the drawing. What we want to do is we want to find the minimum buses. So if we're gonna do a BFS, shouldn't the nodes be buses? B0, B1, B2. So pretend I want to go from station 1. Okay, what we have 0, 1, 2. Oh, sorry. 1, 2. We'll go like this. Like if we're gonna perform a BFS, shouldn't it be on the bus on the buses, not the stations? And the reason I'm saying that is, okay, we want to get to bus. This one. So what's the shortest distance? If we take from 1 to 7, right, and then we just go from like 7 to 6, we could essentially just take bus 0. And then like switch to bus 1 and then get there. What's the other option? We can go from bus 0, ride it to 2, switch onto bus 1, ride bus 1 to bus 2, or ride bus 1 to station 5 and then move over to bus 2, and then afterwards, like switch here. So this is one path, and this one costs 1, and this one will cost 3, right? So
Yeah.
I think you need to look at it in terms of like BFSing on the buses.
Right. So yeah, we can just we start from 1, and we just append onto the queue, or rather, because yeah, if we're starting from 1, then technically 10. Yeah, we have to go through each one separately. Like the really naive way to do this, which might be fine. We just loop through all of these lists, and if it has our current spot, or if it has a 1 in it, then we append that to the queue. So like we append all the spots that are like adjacent, like the bus stops connected here, like their bus number. So yeah, if we're starting from 1, then on the queue we would have bus 0, which is 0 steps, and bus 4, which is 0 steps away. Which I guess, let's see, yeah, we would also want to like have the scene state as part of our queue.
Yeah, this looks good. Come onto the drawing again.
Yeah.
Like how do we know if B0 has an edge to B3?
If there's a bus, if in this case, if 1, 2, 7, 8, or 9 connects to bus 3, which in this case, bus 7 connects to bus 3. Like, or rather, station 7 connects to station 7 in bus 3's route.
Yeah, like if they have if they have the identical station, like if at least one of the stations match between them, they have an edge. Like you can go from one to the other using that station.
Right.
So I think what we just need to work on is building this adjacency list where we just know what buses have edges to the other one.
Okay, so yeah, we have like bus to like connected buses, like, and that would be like, you can use a map for that, like dictionary. So like 0, to it doesn't matter if we use a list or set, but I guess technically list is faster. So like bus 0 connects to we would just loop through all of the individual stations, and you could check if it's connected, basically. So station or bus 0. I mean, all the terminology is confusing here.
Yeah, this is the hard part of this question. It just
So yeah, station bus 0. Let's see, how do we know if it's connected to bus 1? If it has 2, so like, yeah, the really naive way, you just go through each of the other lists, which I mean, we could just convert these to sets to speed things up a bit. Yeah, you just check like for each element. So like for this one here, is it in common with this one? Yeah, it is. So we append that here. And then we move on to number 2 here. So this one, we see that 2 is in common in bus 1.
what's 0
as well.
here?
It's the bus
Okay,
number.
bus to connected buses.
Yeah, so like yeah, the 1 here was in common down here, so we put 4 on the list.
Sure.
Then 2 is here, 2 is visible here, so we put 1 on the list here, which, yeah, I guess this would be a set, so we don't have all the duplicates. Then same with 7. It's in common in bus 3, and so on, like this.
Yeah. Okay, build it out. Like, let's see what it looks like after, and then maybe we could reason about it. Like, what does it look like for bus 1 then after that? Or is there anything left there for bus 0 or no?
Yeah, there is more.
What's left?
Or rather, oh, there's not. Yeah, 8 and 9 are not in the rest. Although, let's see. Yeah, we don't want to add in itself here. Like, you don't want to say bus 0 connects to bus 0. Yeah, so we'll leave that out. And then 1. So bus 1, we check here. Oh, it's connected to bus 0 because they both have a 2 in common. So you put 0 there. And there's no other occurrences of 2.
So bus 1 only connects to bus 0. Doesn't it connect to bus 2 as well?
Oh, yes, you are correct. I didn't loop through all of them. So now bus 2 is connected to bus 1 because of the 5. There's no other 5, but there is a 3 on bus 3. And 3 goes to, let's see, there's a 3 on bus 2. There's no other 6, but there is a 7 on bus 0.
Bus 0. Yeah.
And here there is the bus 0 connection.
Yeah.
Okay, so yeah, with what you were saying, I think you drew the picture before we added in the additional buses, or
the drawing here? Or I think
Yeah.
the drawing reflects what we have here. Without bus 4. Just ignored bus 4. I don't know. Do you see my screen?
I can see the drawing, yeah.
Okay. Like, this is accurate there, I think. Or wait, let's see. Yeah. Isn't it? Like,
Let's see. 0. Yeah, and then 1 connects to 0 and 2. So we need the connection here.
Or I guess all of these are bidirectional. Let's just go with this.
Oh yeah, that works. Yeah, I think this is accurate now.
Mhm.
Okay. So yeah, if we're going from 1 to 6, which the answer might not be accurate still. Let's see. So we're going from 1, we would whoops, up here. So we would have to have the station, like another map, which is station to bus. Or well, that's already what routes is.
Or routes only gives us bus to station, though, right? Not station to bus.
Oh wait, yeah, you're correct. So never mind on that part. Yeah, we would need station to bus. Yeah, we like, should I build this out or?
Yeah, or let's just, because we're almost at time, just let's figure out how we're gonna do the BFS. Pretend we had this. We had the station to bus, so we could say from station 1, we could access like bus 0 and bus 4, right? How would we run our DFS or BFS if we have a queue here now?
Let's see. Wait, hold on. Was this accurate? Bus? Oh yeah. Wait. Station 1, 0, and 4. Yeah. Okay. So now we start from the station. So we would look up in station to bus, and we can put all of those on the queue at once. So bus 0. Whoops. I didn't mean to run that. Bus 2, or bus and steps is what this is. So it's 0 and 0, and 4 and 0, because it's our starting spot. And now we can search here. So when we pop, then we're getting these values. Here, q.pop.
What do we get first? 0 and 0?
What was that?
What do we get first then? 0 then 0 there? Or
Yeah. So yeah, sure. Whoops. It's 0 and 0. So now from here, we have the buses to connected buses, which so we're at bus 0, and we have 4, 1, and 3 as the connected buses. We would also have a scene list here, and well, we haven't seen 4, 1, and 3 yet, but we would mark 0 as seen. And then we can go through all of those places. So that's 4, 1, and 3.
then what do we do? 4 and 3.
So we have the new buses, so we can append those onto the queue with like our steps plus 1. So like it would be something like this.
Do we want to push 4 into the queue?
So we like in the future, we know in the future we're gonna hit this. Or well, yeah, it actually this is what we want because we're doing breadth first search. So even though 4 with 0 was already in the queue, when we hit it the second time with this one, we're gonna see like, oh, this was already seen. So like, or is hit the second time will already be marked as seen, so we don't do the rest. Like we would do a continue part. Like already. Does that make sense?
Yeah, that makes sense. So what could you show me like the next iteration? What the stack is gonna look like?
Yeah. So, after we've gone through 4, 1, and 3. Let's say so. This would have 4, 1, 1, 1, and 3, 1, because it's the number of steps away. So when we hit 4 here, then we go through. We mark 4 as seen. And we have our bus to connected buses. So we would, like we can check. It doesn't really matter whether we check when we're appending or since we have this part up here. I guess it might technically be better to have a check down here, but it doesn't make a huge difference, I don't think. Because it's still like worst case, you'd end up hitting a lot of stuff twice. Well, maybe that's not true, but
Yeah. It could slow it down. Some questions it might TLE if you don't seen it at the right time. I
yeah.
noticed. But let's not worry about that.
Yeah. So you're hitting 4, so we append onto our queue 0, 1, and we'd already seen 0. That was the first thing we went through. And so now we're hitting 4, 1. That's already been seen before, so we're gonna ignore that.
Okay, pretend we go to bus 1, right? Bus 1 pops more things into the stack. Right?
Yeah.
Like, how do we know when to stop and return?
Yeah. So we're trying to get to 6, and we have station to bus. So we look up if the target is in station to bus at our current station, which we have bus to station, which is the routes stuff. So like for route in routes, target in station to bus. Oh wait, this should be like station. Or no, this is bus. Oh my gosh, station. We can just look through all the stations at our current bus. So, or yeah, so this is station.
Yeah.
If target is in, then like we return steps.
Okay, cool. I think we're at time, but what do you think about the question?
Yeah, terminology was annoying, but yeah, it's a good problem. Just annoying to figure out what actually needs to be BFS'd.
Yeah, I think I'll give you two questions that will be really helpful for like where you have to make these assumptions or where you have to do this kind of weird thing. And I messed this up in an interview once because I was messing with the terms as well. But I think one way to solve that is instead of just writing zeros and ones, like actually just do bus zero or like bus like prefix it, right? Because then when you're saying zeros and ones and stuff, it's confusing. Or you're confusing yourself a bit too when it's like, oh, we're talking about buses or stations.
Wait, how is? Oh, you're saying
Or
just
like,
like add these.
just
add-
add like a prefix. Because when you're saying buses to connected buses, this makes sense because they're all buses. But what's here when you're like talking about stations? These are buses to stations. Like I feel like you're just mixing up a bit on that. Like between buses and stations. Like you're mixing up like what you're operating on.
Right.
Even when I was asking for you to describe what's in the map, like the key you would say is station or is bus, and it was like mixing it up a bit, and it's important to, and then yeah, does that make sense or no?
Yeah, just like
It's trippy. Have you tried this accounts merge question?
no.
Okay, try. I'll give you two questions. Try out this question that I asked you right now. It's called bus routes, and then try out accounts merge. These are ones where it's a bit more tricky than just a simple BFS. Because right here, I mean, you could maybe BFS on the stations, but I think with the way you mentioned it, it might return the wrong result. Like it might take the longer route.
Right. Yeah.
But yeah, I think yeah, just understanding the main thing is just figuring out because you understand we had to do a BFS as well. But if you BFS on the stations versus if you BFS on the buses, like it's a slightly different solution. Like you can't BFS on the stations the same way and treat it like how we were BFSing on the buses. You have
Right.
to
Yeah.
do
You
a
need that extra layer.
you have to add an extra layer of complexity or changes and different data structures like mappings. This one involves a bunch of different mappings, like you noticed too, with like station to bus, bus to connected buses.
Yeah.
It's tricky. Yeah.
Is this an actual problem that you said you saw something like it in an interview or?
I got asked that accounts merge one. 721. That's a real interview question. This bus routes is a common Uber question, but people have been like it's pretty common. It's actually legit. But they'll give you the
Jeez.
whole time to work on the question. And if you've seen it before, you should be good. It's not like impossible, it's more just like you just get tripped up on what we should BFS on. Or what we should DFS on.
Right.
Yeah. Yeah, try out accounts merge first, then try to get bus routes. But yeah, cool. I'm gonna hop on with the next person. Thanks for taking the time out to come interview.
Yeah. Thank you.
All right, see ya. Bye. Okay, I think we got the last person today. Shit, I went over too much. Oh, super crack dev. Okay, hop in. Yeah, join the meet.
Yo,
What's
can you hear me?
Sir, what's up?
I'm doing good. How are you?
Pretty good, pretty good. When's the last time you hopped on for an interview?
I think the last time I was on here was about a month and a half ago, maybe.
Oh, damn, that's crazy.
Mhm.
Month and a half. What did I ask you?
Yeah. Oh, it was link list, add numbers, and then some BFS on a tree one. Oh, check valid tree, I think it was.
Oh yeah, I remember that. Nice,
Mhm.
nice. Okay. That's good context.
Mm-hmm.
'Cause then, okay. Have you done a lot of lead code since?
Yeah, I've been trying to do 1 or 2 a day, just keep it fresh. As you know, like interviewing season starts up in the next 2 or 3 months.
Yeah.
But
And what?
yeah, nothing too crazy.
What year are you in again?
I'm technically rising senior or junior. Like I can choose to either fast track master and be a senior, or if I get like a good internship, then I'll delay it and technically be a junior, so I can take the internship. If you know what I mean.
What's it again?
Like I could be rising senior or rising junior. So if I get if I get a good full-time offer, then I'll fast track and be a senior. And if I get a good internship offer, then I'll
I see.
throw some courses in the next year so I can intern again.
Nice. What school do you go to again?
McMaster.
Okay, nice. That's in Canada or no?
Yeah, Canada.
Oh, what the heck? Because I thought you worked at Santa Clara, where you live in.
Yeah, I work in California.
Oh, what the hell? Nice. Wait, okay, I'm gonna grab something. Join in on this link. Yeah, okay. I'm gonna grab something. Give me 2 seconds.
All right, no worries.
Yo, back.
All right.
Nice. Alright, let's start this up. Hey everyone, so today we got a student who's working out of Santa Clara Pure Storage. Yeah, do you want to quickly just give a background on, I mean, he was on here before, so I think what questions did I ask you?
So last time I was on here, I got asked the link list add numbers question and the check valid tree question.
How'd you do on those? Link list, add numbers?
The add number one, I solved pretty much immediately. And then the valid tree one, I came up with the 2 ideas, like the BFS to check it and the 0 in degree to find the root. but I didn't combine them to get the optimal solution.
Okay. And you work in C++, right?
Yeah.
Okay, so we'll switch to language. Okay, that's good context. Now that will help inform us of what questions. What kind of jobs are you looking for post graduation? Are you trying to like do? Yeah, like. what are your
Basically just interesting and high paying C++ work. So that kind of leads you to like distributed systems or databases and storage or quant, right?
Yeah.
So we'll see what offers I get, and we'll see like what the scope of work and the pay is. But basically anything C++ and anything that's like high pay, I'm open to.
High pay is funny. Makes sense though. You gotta make a living.
Yeah, exactly.
What if it's just high pay only?
I mean, it would have to be like if it's a really big difference, obviously, if it's like a 200K jump or something, then I would do probably something more boring like web dev.
Mm-hmm.
It would have to be like a really big jump for me to willingly kind of step out of what I enjoy, which is like C++ optimization.
You really enjoy C++?
Yeah.
Nice. You're different.
Mm-hmm.
Cool. I'm gonna drop in the question. I haven't really worked with C++, but so this is the first question. Since you're preparing for quant, we gotta give you some interesting ones.
Like a turn-based game on a circular field surrounded by circle represents the field.
So I'll let you go ahead and read that and then try to clarify with it.
Okay. Okay, so yeah, there's this number of flowers in between them and clockwise, a number in between them anti-clockwise. Alice goes first and chooses one or the other. It has to compute a number of possible pairs that satisfy the conditions. Alice must win the game. So they just choose a direction and pick a flower. They don't have to. It's not like a coordinates thing.
Yeah, they're sitting in a circular field.
Yeah. Yeah, but they don't have to like move around or anything. They just like grab the flower at the turn. Following pairs satisfy conditions. 1, 2. I'm pretty sure Alice is just going to win anytime there's an odd number of flowers, kind of regardless of the sides. I don't think that really matters at all. Because how the game works is Alice takes a turn. She picks from the left or from the right, let's say, like clockwise or anti-clockwise. And then if there's no flowers left, then she wins, right? So she's going to go first. That's going to be turn 1, odd number, right? If she picks and then there's nothing left, she'll win. But let's say there's even numbers, so 2, she'll pick. Then it's Bob's turn. He picks, and he's going to win. So kind of regardless of if the flowers are on the left or the right, clockwise or anti-clockwise, doesn't really seem to matter. So I believe it's just if there's an odd number of flowers. So I think we have to just find a way, given the N and the M, to find out the number of what is it, pairs that add up to an odd number. So is it that? Let me double check though. Is it just if it's an odd number? So let's win the game. Number of flowers must be in the range 1 to N, 1 to M. Okay, so the reason this doesn't work is because, we can't choose 0. Okay, it has to be 1 to M inclusive. But like, if this was 2 instead of 1, then we could pick 2 and 1, which would be 3, and then this would be 1. Okay. So yeah, I think it's just going to be how many combinations we can get that add to an odd number. So I guess I'll come with a few examples and see if I can find a pattern. So let's see if we do like, start with something small, that's easy to kind of manually work through. N equals 3, M equals 5. So what combinations can we get that are an odd number inclusive? It's just going to be, how do we get an odd number from an even plus an odd number? Because if we add 2 evens, we're always going to get an even. If we add an even and an odd, like 3 and 4, we'll get 7, which is always going to be an odd. If we add 2 numbers, like 3 and 3, we're always going to get an even. So what we need to do is we need to add n as an even to m as odd, or vice versa. So to get the number of, so basically for each even n value, so let's say like in this example we have 3, so the only even n value is 2. But for each of these, we can basically add 1 for each odd value of m.
Mm-hmm.
And then we know from 5 there is 3 odd values. Let's think, how did we get that 3? It's just going to be, okay, so if we do m plus 1 divided by 2. So if we do m plus 1, it gives us 6, divided by 2, we get 3. And then, but what if this was 4? If we do 4 plus 1 divided by 2, that will round down to 2, which is the answer we want, because we will have 1 and 3. And if we have 3 and we do 3 plus 1, that gives us 4. We divide by 2, we get 2. So it seems like this is the correct formula for odd numbers. This will also be true for n. And the number of even numbers, I think, will just be divided by 2. Let's think. If we have n2, we divide by 2. Yep. If we have n equals 3 and we divide it by 2, we should still want 1. This will give us 1. And if we have n4, we divide by 2. Yeah. So it's going to be number of evens, number of odds. And then we have to do this on both sides. So as we can see here in example 1, 1, 2 is valid, but so is 2, 1. So I think we just do return, we'll say n odds times m evens plus n evens plus m odds, which expanded out will be n plus 1 divided by 2 times m divided by 2 plus n divided by 2, this should be times, what was our odds formula?
So for C++, how does this division work? Does it divide up, truncate the value, or
round towards 0, I'm pretty sure.
just rounds towards 0? So
Yeah, like we don't have to do the double slash if that's what you're asking.
okay, so 5 divided by 2 equals 0.
Yeah. No, 5 divided by 2
I mean,
is 2.
2. Sorry. Yeah, 5 divided by 2.
Yeah. If you're asking about double slash like Python, we don't have to do that. Let me just check this formula holds. So let's see. We have this example here with 3 and 2. So what is it? So n equals 3, m equals 2. We want our answer to equal 3. And let's see, from our formula, what we'll get is, so 4 divided by 2, so 2 times 1 plus 1 times 1, which will equal 3. So it does seem to work. And then let's check example 2. It would be, so example 2, we would get 1 plus 1 divided by 2, which is going to be 1 times 1 divided by 2 is going to round to 0, plus same on the other side, which is equals 0. So it looks like this formula does work. Yeah, so I guess let's probably code it up and write some test cases to confirm that.
Yep.
So should it return an int or like a long? Like how big is this? Constraints are n, so 10 to the 5 times 10 to the 5. Yeah, we'll do long to be safe. So long, what are we even being asked here? We'll just call it possible pairs. Possible pairs given an int n and an int m. And our formula was return n plus 1 divided by 2 times n divided by 2 plus n divided by 2 times n plus 1 divided by 2. And then let's make some test cases. So like this 3 and this 5. Yeah, well, let's start with the example ones. So let's do it. Possible pairs. What was the example? It was 3 and 2, and then 1 and 1. So we should expect to get 3. Yeah, we should expect to get 3 and 0. We move this under the new line actually, so it's easier to read. Yeah, so we do get 3 and 0 as we expected. I guess let's try out a bit of a harder one. Let's try and think of a possible edge case here. So, I mean, the edge case of both ones, we kind of already went over. I guess, yeah, let's try 3 and 5.
Let's see. Yeah, this makes sense. Let me just run it on the thing just to make sure you get it
All right.
correct. Yo, Faint, what's up? You're getting the wrong answer for 4 and 4.
4 and 4. Okay.
Yeah, you're getting yeah, I'll let you debug that. You're getting
right.
expected is 8.
4.
Because I wasn't sure how
Yeah,
C++
so,
is like rounding and stuff like that. So.
Okay, so 4 expect 8. So why do we expect 8? We should, because there's 2 odds and 2 evens for each. So that should be 2 times 2, which is 4. Yeah, so it should be 4 on both sides to get us to 8. So n plus 1 divided by 2 should be 5 divided by 2, should give us 2. And m divided by 2 should give us 2, which should give us 4. What is it giving us right now? 9. Okay. So
Like how many even numbers is in here in a 4 supposed to get?
2 and 4.
Or odd numbers. Yeah.
Also 2, 1 and 3.
Okay.
And then let's check this. So 2 and 2. Okay. And then so we're getting 2 and 2. And then we should still be getting 2 and 2 here. M plus 1 divided by 2. And m divided by 2. These should all be 2. They are all 2. What?
These are all supposed to be 2.
Okay, it was some weird order of operations thing. You just need to wrap it in brackets.
Let's see. You run it on the code. Yeah, interesting. Wrap it in brackets, submit. Give me the wrong answer. For 4 and 3?
For 4 and 3 now. What's going on here? 2, 2, 2, 1, 7. Yeah, so let's see. Our number of odds
I
for
think the only thing that
4.
could go wrong is m plus 1.
Yeah.
Let's see. Or like m plus 1.
Well, so m plus 1 should give us.
Let's test it on a few examples. So let's just have, like, how would you test that doing plus 1 divided by 2 yields the right thing?
So with 3, what we want is we want to get the number of odds. So we want to get, obviously, in from 1 to 3, there's 1 and 3. So we want to get the number 2. So 3 plus 1 is 4. And we divide it by 2, which should give us 2. So what we would expect from 4 and 3 is, we would expect, we expect 2 evens and 2 odds in n, which it looks like we're getting. We would expect 2 odds.
Okay,
And
pretend I had
even.
3, right?
Yeah.
So if I have 3, if I'm calculating the number of odds, it goes 3 plus 1 divided by 2. It says 2. There's only one odd.
Well, there's 1.
Oh, there's 2?
There's 1 and 3.
Yeah, 2. There's 2 odds.
Like if we look at the.
Wait, should it be inclusive? Trying to see.
It looks like it's square brackets. It says 1 to n and 1 to m.
I don't know what. Okay, wait, let me think.
What is it?
Yeah, there's 1 and 2. So that's okay. What about
Yeah.
if we do 3 for even? What is 3 for even? 3 for even, you get 3. 3 divided by 2. What is this going to equal? It should equal 1,
1.
right? What does your code
Yeah.
make it equal?
Yeah, it's 1. If you look at the debug output, we're getting 2, 2, 2, 1, 7. 1, 7. Okay. What of these isn't right then? Okay, so we want this to be doing is it this not being wrapped again?
Maybe if we just make some variables.
Okay, yeah, it's
just
wrapped
like
them again.
Yeah.
Yeah, I guess. Yeah, some weird order operations. Yeah. Yes, yeah, we could have put them into variables. So
Let's see. It should. Okay, well, this. Yeah, let's move on to the next question. I think you have it right. It's just it'll probably work now. It's just now we just notice the order of operations.
yeah.
Let's move on to the next question. So we're going to be given a list of n cities connected by some number of flights. We're given an array of flights where flights I is pretty much a flight between 2 cities and the price
Hmm.
to fly. It's essentially describing our graph. So this, I'll show you. I'm going to post in the example here. So our source. So we're gonna be given a list of flights, right? So what it's saying is 0. We can fly from city 0 to city 1 for $100. We can fly from flight or city 1 to city 2 for 100. City 2 to 0 for 100. These are unidirectional. Like, it's just showing the flight. It might not be. I'm not sure. Oh yeah, it might not be the same going back. This is just one way.
Mhm.
Yeah. So we have a list of different flights between cities and the price. And then we're also given a source and a destination. So we want to fly from source 0 to destination 3. And we want to do it within K stops. So this one we want to do it within 1 stop. What is the cheapest price to get from the source to destination?
All right. So this looks like a shortest weighted path within a graph problem. So if there's no negative weighted edges, we should be using Dijkstra's. The issue with the default implementation of Dijkstra's here is that Dijkstra's makes the assumption that obviously the first time you visit that node, it is absolutely the best path. And while it will still be the cheapest price, let's say we visit node 4 for a cost of 5, but it took us 3 stops. There might be another path that brings us to node 4 as well, but for the cost of 6, but in 1 stop, right? So we actually can't mark it deterministically as visited the very first time we visit it, just based upon the price, because although that is like greedily, the best path, we do have to account for stops as well. So we're going to have to find some way to mark it as visited based on the stops and the price. So let's think. We still know the first time we visit it, it's going to be the cheapest price, but we don't know if it's actually the best in terms of stops.
Well, or we're optimizing for stops.
Oh, we're optimizing for price.
We're just optimizing for price, but we need to do it within K stops.
Yeah.
If K is 6, if there's a cheaper path that takes 6 layovers, we still take that path. It's still better, even if it's cheaper. Even though if there's one, that's one.
Oh yeah. I know. I'm saying that there might be. Let's like node 4 in my example was an intermediate node. So let's say like in that example I gave, that the K was 3, and we got to node 4 in 3. If that's not the finished node, then even though that's the fastest path to 4 based on price, we can't use that, right? Because we're already hit our K and we're not the destination. So let's say there's another edge from node 4 to 5, and 5 is our destination for the price of 1. So
Or
there's
are
another
you,
path.
Is there Are you drawing somewhere? Or no.
No, I'm not drawing. But what I'm saying is we need to account for stops as well, even though we're not optimizing for it. Like we'll still use Dijkstra's to optimize for the price.
Yeah.
But when we're checking adjacency lists and pushing into the priority queue, we can't just check if we've been to that node before, because as in the example I just gave, we've already visited node 4, but we can't deterministically mark it as like don't go here anymore, because there might be another path to it that allows us to complete the problem. Yeah. So now I'm just thinking about a way to like how I want to properly mark that as visited to account for that. So I guess we could just do, let's see. So for visited, what do we want to do? Visited, could we do we want to do a visited at K? K price, K. Yeah, do we just want to do visited, like visited NK, which means we have visited node N at K, like at K stops. I should clarify, is K stops the number of nodes in the path or the number of edges?
Edges. let me verify. No, it's actually nodes.
Nodes. Like including the source node?
No, that you have to travel. So pretend if I was traveling in the drawing here, let me go.
Where's the drawing?
If I was traveling from this source node to destination, I would have to this it would be 1. You go here, go here. So there's only one stop.
Okay.
One stop to get there. Like going direct is not a stop. You don't have to stop.
All right. So, okay, so k plus 1 is equal to max edges. Yeah. So k plus 1 is equal to max edges. No. There's no done. Yeah, so I think what we're going to want to do is Dijkstra's, but instead of just checking visited, we will check. Yeah, we will have to do visited for k. And then like we can deterministically say that if we've already been there. Actually, wait, I don't think, maybe we don't have to do 2 dimensions here. We have visited, yeah. Let's say we'll call this unweighted distance. So at n, we have visited node n, like this, the value here will be, we visit node n at k edges. And then when we go to check through the adjacency list, we'll check if our number is less than this. So if our number is less than this, then we still push it as a possibility and we update it. But if it's greater than it, then we can pretty deterministically say, well, this is not a route we want to pursue, because this means we've already gone there in less unweighted edges, so less than k stops. And we have gone there in a shorter distance just based on how Dijkstra's works. So there would be no reason for us to pursue that path.
Mm-hmm.
So basically the steps we'll do is we'll build adjacency list. We will init our priority queue. We will init our unweighted distance vector. And then we will we'll push source, and then while not queue empty, hop front, check if at destination, check if, yeah, so the graph actually is going, what we're going to need here for our value is going to be our weight and the number, like the unweighted weight, basically. So it'll be weight, unweighted weight, and then just the node number. We'll call it that U. We'll check if at destination. We'll check if unweighted equals k plus 1. And in that case, we just continue. We can't pursue this any farther. We've already hit our max number of edges. And then we will loop edge list U and push any path worth pursuing further, which will be if weighted distance at V is less than UW plus 1. And then we'll just continue until we're at destination. And then what do we do? Yeah. And then if we don't do anything, we return -1 at the end. That would be our kind of logic flow.
What's W, UW, and U? Like what's weighted?
So,
weighted?
yeah. weight, unweighted, which is num edges and path, and then U per node.
Weight,
And here,
weighted.
V equals adjacent node.
What's the unweighted for?
To check if this path is like worth pursuing. So basically in this like distance graph, the only reason why we would want to go to V and like continue down this path is if we either haven't been to V before or we have been to V before, but it took us more unweighted distance.
Okay. Like, why not just label this number of edges or something like that? Like unweighted. Or like, why do you pick that variable name of unweighted?
Like no specific reason.
Okay, I'm just wondering. Okay.
Like yeah, it could be anything.
Okay. Just
So does that make sense? The logic.
I think so. Let's go ahead and implement it and just figure out if it's all working.
All right. So what are we returning? Returning an int. Let's say, what is this? Cheapest flight, and what are we taking in here? We're given vector int, which is flights. Vector. Okay, so basically, like I said, first thing we want to do is build our adjacency list. So first, let's get the number of nodes.
That's input as well. Like we're given 3 inputs: n, flights, and source, destination, and k. So,
Okay. Int n flights.
we're given flights. We're gonna be given the source, destination, and k. Yeah. And source.
Int k. Int source. Int des. Wait, does it say n number? N cities. Okay. Yeah. So one second. Let me plug in my laptop.
Yeah, no problem.
All right. Okay, so we have n already. So what we're going to want to do then is make our adjacency list, which should be a vector of vectors. Basically, how we'll do that is we will just loop over flights. So for each thing in flights, what we're going to want to do is edge at f at 0 is our from. We want to push back the node we're going to, which will be f at 1, and then the price, which is f at 0. That should not be int, then it should be all right. So there's our adjacency list, and then we want to initialize our priority queue. So priority queue of what did we say we wanted? We wanted weight, like number of edges, and node. So we'll have that as a tuple. So priority queue, then vector. And then we want, okay, so priority queues are normally max queues, but we want it to be min. So switch that. Priority queue greater queue. I need to include priority queues. Include. And where do I include priority queues from? Priority queue. U. Okay. Okay, there we go. So initialize priority queue, and then PQ dot push, and we said so weight will be 0, edges will be 0, and then source. And then next thing we'll do is initialize our unweighted vector. So vector int unweighted distance n, and then we want this to be the max initially. What is this? Limit. Okay, so yeah, initialize our unweighted vector, and we want to push source, so we did that already. We're also going to want to send unweighted distance at source equal to 0. And then, yeah, well, q not empty. So well not q dot empty. What we are going to do is get from the front of the queue. So auto weight edges and u is equal to pq dot top, and then pq dot pop. And then we want to check if we're at distance. Okay, yeah. So if u equal distance, return w. And then what's our next check? Check if, if edges equal k plus 1. We cannot continue down this path any further, so continue. Yeah, and then we're going to loop over the adjacency list. So for in const v in edge u, if away distance at v less than, oh, we need two things from here actually. How do we make the adjacency list? It was v and then vw. So if unweighted distance is less than what? Less than edges plus 1, because that's what we'll be visiting this at. Right. Yeah, less than edges plus 1. Then away distance at v is equal to edges plus 1, and we can push this to the queue. So our queue is weight, so VW plus, yeah, so W plus VW, then edges plus 1, and then V. And then -1. Why is that saying that? Okay, so yeah, so we make our adjacency list. So from to thing, we make our priority queue, and we want the lowest weight at the front, and then we got unweighted distance graph, track distances. We put in a max initially because we want to have the smallest one. Yeah, we put that in, put source in for both of them. Mm-hmm. Then we go through our queue, we get the weight, we get the edges it took us to get here, and we get the current node, and we pop it. If we're at the distance, we can return the weight it took us. If we can't go down this path any further, then we skip and try a different path, and we get everything from the adjacency list. We check if this path is worth pursuing, and if we do, we update it, and we continue down. Oh no.
So unweighted distance is, so we're only pursuing it if it got us there in less edges?
Yeah.
Okay, let's run it on a few cases.
All right.
Like, I'll just get some. No problem.
Adjacency list. Unrelated distance source. Check effects. All right. Two, 0, 100. 1, 3, 600. 2, 3, 200. Plates. What was K here? K is equal to 1. Source is equal to 0. This is equal to 3.
There's improvement 100 or 700. Oh shit. Hold on. Error. The input.
Oh.
It's like giving the wrong result. It's giving us negative
Yeah.
1.
Okay, let's see. Did I put this in right? N equals 4. Flights equals 0, 1, 100. 1, 2, 100. 2, 0, 100. 1, 3, 600. 2, 3, 200. Then 4. Source. Wait, no, K equals 1. Yeah. Source equals 0. This equals 3. Okay. So, yeah. Let's see. So, okay. I guess let's check what it's actually doing here. It's only visiting 0. What? Why is it doing that? Oh, this is the wrong way.
Nice.
There. Okay, so
Running on the other examples.
yeah. Okay, so second example, N is 3. Then we'll update flights. Source will be 0. Destination will be 2. K will still be 1. But we're going to set flights equal to 0, 1, 100. 1, 2, 100. 0, 2, 500. The second one, and this last one.
All right, let's go with the second one for now. Let's see.
All right. 500. Go. What, did I put this in right? 0. Was it source 0? Destination's 2. K is 1. Okay, yeah, there's something. 0, 100. 1, 2, 100. 0, 2, 500. Okay, so it is initially at 0, 0, 0, which is correct. And then from 0, yeah, it should be visiting either this or this. Yeah, and it correctly visits this next. So we're at 1. Yeah, we're at 1. Yeah, we're at 100 weight with 1 edge and at 1. But then we go to 2 for some reason. Does this not get pushed? Oh, because we found. Okay. Okay, so this middle edge isn't getting pushed, even though it should be, because we found a path in less K. But yeah, it's not optimal. So how do we fix this then? Instead of only pushing it for unweighted distance, what can we do instead? I think
Wait, distance is less than. Look, why are we only pushing it if it has less edges? That's the part that I was curious about.
Let me try this. There.
What did you add?
I moved where we mark it as visited, but let me double check that's actually correct. Okay, what I'm thinking, the reason I'm doing it this way is what I'm thinking is, that edge case I was trying to explain earlier, where like an intermediate path gets us there with less price, but it's not the actual best path because we took too many edges to get there. And there might be a more expensive path that takes way less edges that does actually allow us to get to the final. So we can't just do a straight up like visited or not visited kind of binary set because of that, which is why I'm doing it this way. You might get TLE with the cout statement in there.
I'm trying to just copying and pasting it. Give me a sec.
Yeah. 700, 200.
Run it on the last example. Let's see.
Yeah. 0, 100. 0 to 500. Source is 0. This destination is 2. K is 0. N is 3. Yeah, it passes all three that you pasted in here.
Wait one sec. Just getting a weird error when I'm posting in leak code.
Oh, it's because I'm using type aliases probably.
No, I had that. It was working initially, but fine cheapest. Are you looking at the stream?
No, let me switch
wait,
over.
let me invite you to the leak code link. Pop it over. I'm posting it right here in the shit. The fuck. We're posting it into our meet.
All right.
Edges. See when I run that? Okay.
It passed. Yeah, you're missing a bracket.
Oh shit, where am I missing that?
This, if you can see where I'm highlighting right now,
Nice,
this one was missing.
Nice. Okay, sick. Good job.
Thank you.
Nice. What do you think? How was that? How did it go?
I think we
We're
went
pretty much
pretty
at
well.
time.
Yeah, I mean, a little bit more debugging than I would have liked on both questions, to be honest. But I think in terms of understanding the questions, and like solving them, it went fairly well.
Yeah. You were able to pretty much understand. Like the main thing that I see in people when I ask this one is they wouldn't understand to use Dijkstra's. I mean, you figured that out pretty much right away. It's like some people try a weird DFS solution, and then you understand that it's not just regular Dijkstra's. You're gonna have some slight variant to just account for the edges. And for the first one, I think it was good intuition to quickly find out that it doesn't really matter left side or right side. It just matters if it's odd or not. And then
Yeah.
finding out the equation to calculate how many odds given n and m, right? The main thing was just the small issues with the way that you're combining it. Yeah.
Yeah, I guess if I separated that one out in the variables, that one would have passed the first time.
Yeah, it would have made it probably a little bit
Yeah.
easier to look
Mhm.
at.
Yeah.
And I wasn't
And then
that
this
sure
one-
with C++. I was because some languages when you divide, sometimes it rounds up. I think in Java, I didn't remember. There's some language where it round up. I don't know, but overall, no. I think you solved the question. That was good stuff. Guess next time we're gonna ramp it up even harder.
Yeah, it rounds towards 0. You can see even this negative
Yeah,
one
that
divided by
makes
2
sense,
is
yeah.
0.
Or rounds towards 0. Yeah, that makes sense.
Yeah.
Okay, Mr. B said Java doesn't round up. Or what I mean, yeah, rounds towards 0. So if it's negative, it goes up. If it's like positive, it goes down. I don't know how it works
Yeah.
in Python. I think it just rounds down no matter what, even if it's negative. It doesn't round towards
Like with the
0.
double slash?
Yeah,
Yeah.
it's like weird stuff like that you just need to worry about. But
Mhm.
no, I think you do good though. Next time we'll ramp it up even harder.
Yeah.
Yeah, cool. Sounds good. All right, catch you in the next one.
Perfect. Thank you.
Peace.
Peace.
Java doesn't round up. Okay, my bad. I don't use Java too much. Java doesn't round up even if it's a negative. I don't even really. On to right. Yeah, the way I did that is I would just divide and then take the ceiling. Nice, cool. All right, that's about it. Gonna enjoy my Sunday for the last little half. Probably gonna have to head into the office tomorrow, but I think we had some good sessions this weekend. We did like 15 interviews this weekend, which is insane. That's enough videos to last me up until July. Stay tuned for Juneteenth, Thursday. I'll be streaming even longer, a super long shift again. We have a lot of open slots, so please book 1, 2, 3. We have 4 open slots left on Thursday. Yeah. Cool. All right. Peace out. I'll catch y'all in the next stream.